sir. We can hear you loud and clear. Thank you.
Okay.
Thank you for joining us.
Great. Thanks, Sandeep. Thank you very much. Sorry for the slight delay.
It's on time, sir.
So what I'm doing, I'm actually logging in from two of my devices. One is being used for the video and the audio, and other will be used for the whiteboard if needed and the presentation. Let me share my screen. Here we go. Is it possible, guys, to turn on your videos so that I can also? Is it possible to turn on the videos of all the participants? You can also you can mute your mic, but it would be good if you turn on your videos, at least a few of you, so that I do not feel that I am alone. Sandeep, is it possible? Yeah, great. Thank you very much. So I also hope that you see my screen, right? You can see my slides, and also you can my voice is clear and the video is also clear, right? Okay, so how many participants are there? Around 34? Right.
Actually, total number of participants are 45 around, but I don't know. They will join in some time. I mean, you can start, Professor.
Yeah, I will start. Just give me 1 minute. Okay, so a very good afternoon to all of you, and a very, very happy new year to everyone. My name is Tanmoy Chakraborty. I'm a faculty at IIIT Delhi in Computer Science Department. I mainly work in the areas of social network analysis, natural language processing, at the intersection of these two broad areas. And I also do work on a field called complex networks, understanding network structure, graph structure, using graph structures and solve real world problems related to networks, right? So before going into the details of today's presentation, I'll quickly give an overview of a very 1 or 2 minutes overview of the group where I belong to. I lead a group called LCS2, Laboratory for Computational Social Systems. I can't see other face actually. I can only see Sandeep. Is this because of the setting? Yeah.
No, I request participant, please turn on your camera. Please,
if possible. It's not mandatory, but if possible. And please, guys, please feel free to interrupt me at any point in time. Okay. You should not keep your questions till the end. You just unmute and ask at any point in time if you have any query. So I, as I was mentioning, I will lead a group called LCS2, Laboratory for Computational Social Systems at IIIT. We are a group of students, PhDs, postdoc, RAs, and other masters, undergrads, mostly working in, as I mentioned, two areas, broad areas, NLP and graph mining, complex networks. In NLP, currently we are interested in two problems. One is called text summarization. Another is called conversational dialogue modeling. In text summarization, we mostly work in abstractive summarization, abstractive text summarization. I am sure that some of the speakers in this winter school will talk about it in the later part of the school. And in conversation dialogue system, we are interested in in modeling conversations, designing chatbots for different applications. Currently, we are focusing on designing chatbots for banking purposes, because we have got a project from banks, and we are designing chatbots for them. In graph, it is also called complex networks. In graph mining, we are interested in problems like understanding graph structure. There is something called communities in graphs, and we are also interested in different types of attacks in graphs, right, and so on. In particular, our major focus these days is at the intersection of these two broad domains, mostly in the areas of social computing, and we are working in these three broad areas. One is this hate speech, other is fake news, and the third one is collusion in social network. These three are funded projects by Google, Accenture, and Wipro. If you are interested to know more about the group activities, etc., you can visit this website, right? And we also maintain our Twitter handle very regularly. So if you are interested in some of the research that we do, please feel free to look at and contact us if needed. So now this is the plan for today's lecture. Okay, I'm going to talk about language model, mostly pre-deep learning era, when we are interested in statistical learning and mostly statistical understanding of languages. I'll talk about very fundamental language modeling techniques, and because I was told that this is one of the, I think, first sessions in this winter school, so participants may not have ideas about deep learning and stuff. So this session will give you a handful of ideas about language model, statistical language model, and first 2 hours will devote mostly to understand theoretical concepts, and the last hour Sandeep and his team will help you give some hands-on experience, and if you know Python a little bit, you can code it, and they will help you throughout. Okay, and as I mentioned, if you have any query, please feel free to interrupt me at any point in time. Is it safe to assume that you guys have preliminary ideas about NLP? For example, you know the jargons, the technical terms that we use, for example, types, tokens, lemmatization, tokenization, etc. So
yes, sir.
how many of you absolutely know, I mean, how many of you have no ideas about NLP, zero idea about NLP? Can you unmute very quickly? Zero idea. Okay. You can also chat. Yeah, you can put in chat. Okay. So, okay. And how many of you have decent ideas about NLP? For example, you know, say Ingram modeling, perplexity, parsing, etc. Okay.
I know, sir.
Okay.
I also know, sir.
Okay, great. So in that case, this session is going to be slightly boring for you guys, those who have some ideas about the fundamentals. Okay, because the plan was to give a very basic ideas about language model, how to evaluate, etc. But yeah, it would be great if you also participate, because I keep asking questions in between. Okay, so those who have ideas about things, please unmute and respond to my questions. Okay, great. So you have possibly seen that there are different applications in NLP. For example, we talk about say text summarization. We talk about information extraction. Where given a text, your task is to say for example, you are given an email where it is written that a meeting has been scheduled on 21st of January, right, at this venue, right? So from this email, the task is to automatically identify the location of the venue, the date of the venue, and if possible, automatically mark your calendar with all the information, right? This is information extraction. Then sentiment analysis, we have also seen that given a text, say a movie review or a review of a product, right? So the task is to identify, to understand whether it is a positive sentiment about the product or the negative sentiment or the neutral. And if needed, you can also gauge the intensity of sentiment from a scale of say, between 0 to 10, right? Similarly, emotion recognition is also another task of NLP, where you basically try to identify the emotion of the speaker to a particular product or to a particular event entity, right? Sad, happy, etc., etc. Other applications include, say, machine translation is again another application where say you are given a text in one language. Say, for example, you are given a text in English language, and your task is to translate the sentence into, say, Bengali or Hindi, right? Now, these days, in the era of social media, we generally use multiple languages together. It is called code mixed language or code switch language, where we use English and Hindi together, English or Benglish, right? These kind of languages. So handling code mixed languages for machine translation is even difficult than a monolingual language like simple Hindi or simple English, right? So in all these applications, one of the major components is language model. Okay. Language. What is language model? If I ask in a very abstract way, what is language model? I would say that language model, this is not a bookish definition. So language model basically tries to synthesize a language, right? What do you mean by synthesize a language? For example, your task is to synthesize Rabindranath Tagore's writing, right? What does it mean? It means that your algorithm or your system, your language model, should be able to recognize Rabindranath Tagore's writing, should be able to generate text which looks like Rabindranath Tagore's writing. Okay, it means synthesizing the text. Okay, so so this is this is a very abstract definition of language model. In a more in a more theoretical definition or a more systematic definition would be basically language model tries to predict the next word in a sentence. Okay, or in another way, you can say that language model tries to predict the probability of a sentence. Given a sentence, how can we measure what is, I mean, how probable the sentence is, right? Giving some training sample. For example, if the sentence looks like this, I notice 3 guys standing on the dash. Okay. Now this is the first part of the sentence, and your task would be to predict the next word. Okay. How do you do that? How do you do that? A simple approach would be you go to the existing training sample that you have, existing text that you have, and you look at the phrase like on the. Okay, you see that how many times this is called bigram. Okay, 2 words at a time, two consecutive words at a time. So you look at this the word on the in the entire corpus that you have. I hope you know what is corpus, right? Corpus is a document. In NLP, it is basically we do not use the term document. We generally use the term corpus, and the plural of corpus is corpora. Okay, collection of documents. So we look at the corpora or corpus, and we will see that where this particular bigram appears on the, how many times it appears, right? Then you also look at what are the possible words which follow this bigram on the, right? Say, for example, you see on the table, on the chair, on the floor, right? On the roof, on the grass, on the field, right? You look at all the occurrences, and based on these occurrences, you basically decide what is going to come in this particular position. Okay. So essentially you're counting, right? So now this is a very simple, very naive idea of predicting the next word, but there are many problems, as you possibly understand. That first problem would be why we are taking only 2 words, why not 3 words, or why not the entire set of words preceding the particular word, right? And so on and so forth. There are multiple things that need to be considered, and we'll discuss these things one by one. So an appropriate an accurate language model should be able to predict the word, what is going to come at this particular position, which word will come in this particular position. That's the target of the language model. Okay. So now word prediction is just one application. There are many applications, right? But in general, we can formulate the task of language model as a word prediction task. Now, so pre deep learning era, we mostly talked about n-gram based language models, where we looked at 2 words before the given word or 3 words before the given word, and then we try to decide which word is going to come, and so on. But after this deep learning, this boom of deep learning, we basically do not use this n-gram language model. We now look at more sequence labeling approach like LSTM or GRU to predict this. I'm sure that this will be taught in the subsequent part of this winter school. So now applications of language model. One application, as I already mentioned, to predict the next word given a set of words, sequence of words. And these are the other applications. For example, it can also be used in speech recognition. Okay. For example, you want to utter this particular sentence, I ate a cherry, right? But you uttered in such a way, yeah. So, but assume that your utterance sounds like this: I ate a cherry. Okay, so your language model should be able to say that this, and you assume that you are using some speech to text converter, right? So using some speech to text converter, you got this phrase, I to a zeri, right? So your language model should be able to say that the probability of this sentence is very, very low. Okay. And then there are different ways to automatically correct it. But your language model should be able to say that the probability of this sentence is very, very low. And of course, it can also be useful for handwriting recognition or optical character recognition, as you understand, right? The same thing. It is also used for machine translation, as I was mentioning. So the task of machine translation is that you are given a source text, say in one language, and your task will be to translate it to a target text, right? Say Hindi to English or English to Hindi, whatever, right? Now, if you have a good language model which recognizes this text very well, it should be able to it should be able to add to the machine translation model. Okay, it is also useful for context sensitive spelling correction. Okay, say look at this sentence. There are problems with this sentence. Okay, now, if you look at individual words, all the words are correct, right? But WYT with should not come here, should not come before problems, or should not come before this. So your language model should be able to say that, again, the given this word, given this sequence of words, there are problems. The next word should not be with. Okay. So a very quick recap of some of the basic terminologies. I am pretty sure that you guys know, but still, types and tokens. Difference between types and tokens. What is type and what is token? Anybody wants to respond? What is the difference between types and tokens? Anybody wants to unmute and respond?
Sir, Tokens is the number of running words,
Mhm.
number of words in the document. Tokens are going to be the distinct number of words that are going to be making the vocabulary.
This is just the other way around. So tokens are the number of running words, and types are the number of unique words. Okay. Say for example, let's look at this sentence. Okay. He stepped out into the hall with was delighted to encounter a water brother. Forget about the meaning of the sentence, right? So how many words are present here? How many running words are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13 words are there. So there are 13 tokens. Okay, if you include this punctuation like comma, right, and stop or full stop, right, then there are 15 tokens. Okay, how many types are there? So I think all the words are unique here, right? All the words are unique here. Let's take another example. Let's take this example. Okay. They picnicked by a pool, then lay back on the grass and looked at the stars. Okay, how many tokens are there? 1, 2, 3, 4, 5, 6, including comma, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 tokens are there, right? But how many types are there? Types are number of unique tokens. If a token is repeated multiple times, then we'll only use one, a count of one, right? If you look at here, the word the appears 1 time, 2 times, 3 times. Okay, so we will consider only one appearance of the word the. Other words are unique, right? So essentially 16 types are there, right? Difference between types and tokens. Depending upon the application, sometimes what we do, depending on the applications, instead of just looking at the running words and identifying unique words for types, what we also do, we sometimes use stemming or any lemmatization algorithm, right? Get the stemmed word, and we looked at unique stems, right? For example, if in a sentence the word like cry and crying is present, right? Cry and crying both are present. In normal sense, we consider both cry and crying as two different types. But in some cases, when we use stemming, then or lemmatizer, then both these words map to the stem word cry, right? In that case, we only use one, either cry or crying, as a part of this set of types. Okay. Yeah. So someone wanted to ask something.
Yes, sir. I just wanted to ask, is types the unique tokens?
Unique tokens. Yes, okay. Yes. Unique tokens. Unique tokens in the sentence.
Okay.
Right. So we will use these terms later. Now coming to the goal again, the goal of language models is to remember these terminology, types and tokens. We'll use them in the rest of the presentation. So the goal of the language model, as I was mentioning, is to measure the probability of a sentence. Okay. Now how, I mean, you may feel that the definition is slightly vague, but we'll try to quantify it later on. Okay. For example, if there are, say, two sentences like this: high winds tonight and large winds tonight. Okay, your language model should be able to say that high winds tonight, the probability is higher compared to the probability of the sentence like large winds tonight, because possibly the word large should not appear before winds. Okay. As I was mentioning, spelling correction, right, in handwriting recognition on OCR, right? Say, for example, about 15 minuets or 15 minutes, right? It should be able to identify that this word, right, minuets, this is a wrong word, right? And this is a correct word. So therefore, the probability of this phrase is higher than the probability of this phrase. Okay. Speech recognition, I was mentioning, say for example, you have a sentence like "I saw a van," and you have and then your speech recognition basically recognized in a different way. It sounded like "I saw of an," right? So your language model should be able to say that the probability of this sentence is higher than the probability of this "I saw of an." Look at this sentence, right? Individual words are all correct, right? But at a sentence, this is an incorrect sentence. So the probability should be lesser than "I saw a van." Okay, summarization, question answering, and many applications. So,
Sir,
yeah,
I have a doubt, sir.
yeah, go on.
You were comparing the probabilities of the sentences based on what corpus you're given
Yes,
with, right?
based on some corpus, yeah.
So if that is corrupted, then the whole idea.
So this is a very good question. Now, if the corpus is corrupted, in most cases we assume that the corpus, I mean the majority of the corpus is not corrupted. Of course, there are noise here and there, but in most cases we assume that the noise is negligible. And if you think of it from a statistical point of view, statistically the probability should be higher than the other one.
Thank you, sir.
So now let us try to now understand how to measure the probability of a sentence. Okay, that is very important. So now when you talk about a sentence is a sequence of words, or a phrase is a sequence of words, and assume that this is the sequence of words, W1, W2, these are the words, ... Wn. There are n number of words in the sequence, in the sentence or a phrase, right? So we basically say the probability of this word. So we try to measure the probability of this entire sequence W. Okay. Now this is the probability of measuring us probability of a sequence is same as. So essentially, think about it. This is a joint distribution. Probability of W1, W2, ... Wn. This is a joint distribution. I hope you know what is joint distribution, right? Right?
Yes.
Yes,
So,
sir.
so probability, this joint distribution, joint probability, when we have the joint probability, how can we convert it to a conditional probability? Let's take two, let's take only two words, W1, P of W1 and W2. How can we write this in terms of, say, P of W2 given W1? Any idea? Or what's the relation between joint probability and the conditional probability?
The right hand side multiplied by probability of W1 will be the left hand side.
So you are basically saying that P of
W1
times P of W1 is this one?
Yes.
Any other answer? Anyone wants to counter this? Anyone wants to counter this? No? So this is correct. Okay. And what we do is that what we say in general is that probability of measuring the probability of a sequence is equivalent to measuring the probability of this conditional probability. Okay. So essentially, this is P of W1, W2, ... Wn is equivalent to measuring P of Wn given W1, W2, ... Wn minus 1. Okay. So in other words, the task of a language model is to predict this conditional probability, right? It basically says that this is fill in the blanks, right? So given you have W1, W2, ... Wn minus 1, these are the sequences. What is going to be the next word? What is going to be the nth word? Okay. Whether the nth word is ball, or nth word is park, or whatever, right? So we need to predict this one. Okay. So in other words, if you think of it carefully, we are trying to predict, we are trying to measure the, we are trying to predict the grammar of a language, right? If I say that, if you remember the first sentence, right? The example that I gave, something on the desk. Now, if your language model is good, you should be able to say that the next word on the next word should not be a verb. It should be a noun, right? So in other words, it is trying to capture the grammar, but in an intrinsic way, not in that, not at the explicit way. With kind of implicit way, it tries to capture the grammar as well. Okay. So now coming to the measure, how to measure the probability. So the probability that given this sequence P of probability of its water is so transparent that this is the sequence, and our task would be to predict what is going to be the next word, whether the next word would be the, or whether the next word would be chair, next word would be table, or so on, right? Now assume that you have a vocabulary, right? In the vocabulary there are unique words present, right? You choose one word at a time, you place here this word, and you measure whether this word is suitable or not for this position. You do it for this word, you do it for this word, and so on, right? And then you see for which word the probability is highest, maximum, right? So then you choose that one as the appropriate word for this position. Okay. Say for example, you want to predict this probability for the word the. Okay. So now what is your sequence now? Its water is so transparent that the. This is the sequence, and your task would be to predict the probability of this sequence, right? So what is the way to measure the probability? The idea is very simple. You look at the count. In your corpora, in your training sample, you see how many times the whole sequence appears. Its word is so transparent that the, divided by how many times this sequence, its water is so transparent that appears. So essentially you are saying that out of all the cases where you observed the phrase its water is so transparent that, out of all the cases, how many times the follows this phrase, right? Okay. So is this clear, or if you have any problem? So you have your training set, right? Say let's give a simple sequence. I am a boy. I am dash. I am a dash. Okay. So you basically count. Now your task would be to predict which word will come here, right? You count and say you take a word from your vocab and say the word is girl. Okay. You count how many times this sequence, how I am a girl appears in the training sample, divided by the count I am a. Right? You do it for girl, do it for boy, cow, dog, whatever words you have, and then you choose that word for which it is maximum. Now, what's the problem here? Tell me.
So this model might not be able to handle words that are not there in the vocab.
Exactly. So that is not a major problem, in the sense that we generally assume that most of the words are present in the training set. Okay, but here the problem is, if the length of the sequence, okay, say for example I am a, there are only 3 words. if the length of the sequence increases, it is very, very less likely that the sequence appears in the document. And therefore, it is highly likely that the count of the numerator would be 0. Even the count of the denominator can also be 0. Right? You understand, right? The more the length of the sequence, the preceding sequence, it is less likely that the sequence will appear in the document. That's the problem. We'll see how to solve this problem. So, in general, we have already discussed this one, right? So this is I hope that you know chain rule in probability. Okay, P of W1, W2, W3, W4, W5, for example, right? We can break it into P of W1 times P of W2 given W1 times P of W3 given W1, W2 times P of W4 given W1, W2, W3 times P of W5 given W1, W4. Okay. So to measure the joint probability of this entire sequence, we basically divide it into several conditional probabilities and then we multiply them, we get the probability of the joint probability of the sequence. Right? So same tricks we apply here. So now in order to compute this one, probability of its water is so transparent that what we do, we use the same trick, the chain rule, and we divide the joint probability into conditional probabilities. P of its times P of water given its times P of is given its water, so on and so forth. We compute these probabilities one by one. And how do we compute it? We already know how to compute. So how do we compute P of its? Probability of its. Probability of the word its. Very simple.
Calculate the number of times.
You look at the corpus and see how many times count of its divided by n number of words, total number of words, right? How do we measure this one? Probability of water given its. So count of its water divided by count of its, right? How do we count this one? How do we measure this one? Is its water. Count of its water is divided by count of its water, right? And so on and so forth. So, right, this is the way we measure the conditional probability. Okay. Now try to understand the interpretation. Okay, this is not like something to remember. It is basically saying that given that you have the sequence, its water is so transparent that what is the probability that the next word is the, right? So the idea is very simple. You look at the count of all the cases where this sequence appears, which is the denominator, and you see out of all these cases how many times the sequence is followed by the word the, right? So counts of it, its water is so transparent that the. Okay. So the problem we already seen, if we do not have large amount of corpora, it is highly likely that you would encounter a count of 0 in most cases, and then it would be difficult. So what we do in this situation is that we take some assumption. Okay, what we assume is that, for example, here the assumption is that, so the assumption that we take is that in order to predict the next word, instead of looking the entire word sequence, the entire sequence before the given word, we only look at a few words, not the entire sequence. Possibly we look at last 2 or 3 words. Okay, so in order to predict whether it would be da or not, we will only look at, say for example, only last 2 words, transparent that. Right? So in that case, this probability boils down to probability of the given transparent that. And how do we count it? How do we measure it? Count of transparent that the divided by count of transparent that. Right? Now since your previous sequence, the length of the previous sequence is now decreasing, has slightly decreased. Earlier it was a length of 1, 2, 3, 4, 5, 6. Now it is a length of 2. Right? It has decreased. Therefore, it is highly likely that you may not encounter. I mean, it is highly likely that you encounter such sequence in your training set. Count may not be 0. Okay. Now, whether to use 2 words or 3 words or 4 words is something that we need to assume. Okay. So Markov. Andre Markov, you possibly know Markov, right? We know Markov chain, Markov assumption, many things. So Markov, one of the assumptions that we borrowed from Markov's rule is that we only look at 2 words or 3 words before the given word, and this is called and depending upon the assumptions. So sometimes it is called Bigram assumption. If we look at last 2 words, this is called Bigram assumption. If you look at only 1 word before the previous word, it is called Unigram assumption, and so on and so forth. Right? So how many of you know what is first order Markov model or second order Markov model, 0 order Markov model? Any idea? Anybody has gone through this theory of automata?
So what you just told, I mean, considering only the previous sentences, I mean, like independent of any word that has appeared before is the 0th order, and considering the first word before the given word is your first order, and similarly second order.
Very good, very good. So let me briefly explain what is first order Markov process, what is second order Markov process, and so on. Okay, so those who are of CS or IT background may have ideas about this finite state automata, right? State transition. Let us assume that. Let's take a funny example. Let's assume that whatever you do every day when your college is on, right? Those are your states. For example, you wake up, right? You wake up at 6 at the morning, right? Then you do your breakfast. Then you take your breakfast, right? Then you go to college. So you arrived at college, and then you take your lunch. Okay. Then then your college is over. You again return to your home, right? And so on. These are your states. Okay. These are the states. Okay. And then there is a trigger which moves you from this state to this state. Right? There's a trigger which moves you from wake up to taking breakfast. There's a trigger which moves you from breakfast to college. Sometimes you want to bunk your college. So in that case, you directly you move from breakfast to lunch. Otherwise, from college, you move here. Okay. From lunch, you again return home, and there are other activities. Right? So there are something which is triggering you to move from one state to another state. So now say, for example, you are at a particular point in time, you are at this state. This is you. Okay. Now you see that there are 2 possibilities. Either you move to this state or you move to this state. Right? In case of first order Markov process, first order Markov process or Markov assumption, whatever, right? So whether you move to the state lunch or you move to the state college, it depends on your current state. In zeroth order Markov process, whether you move to lunch or you move to college is independent of the current state. Right? For example, you just toss a coin and you decide. It is independent of your current state. It's called zeroth order Markov process. Second order Markov process, whether you move from whether you move to the state lunch or you move to the state college depends on your current state as well as your previous states. So this age is now determined by this probability of moving to the state lunch is dependent on your current state, which is breakfast, and your previous state, which is wake up. This is second order Markov process. First order Markov process, this age is determined by, in case of first order Markov process, this is probability of lunch given breakfast only. Right? Remember this terminology. Similarly, second order, third order, fourth order, and so on and so forth. In case of language, NLP here, in language model, states are basically words. Okay? So the next word is, whether the next word is da or table or chair, if we assume that it is a zeroth order Markov process, it is then independent of the previous words. Okay? Remember the previous, so this is the previous words, these are the previous words, right? This is also called the context. Okay, context. So in case of zeroth order Markov process, right, or Unigram assumption, it is independent of the context. It is so in case of Unigram assumption or zeroth order Markov process, this probability is equivalent to probability of the. This is Unigram language model, right? Bigram language model or first order Markov process, P of the given the last word that. In trigram language model, P of the given transparent that. We look at last two words. Okay, so these are the assumptions. So you need to take one as an assumption in order to proceed to the next stage, right? So as I was mentioning, this is corrupted. I do not know why this is not coming, but essentially it is saying that P of W1, W2, Wn is equivalent to product of P of all Ws. So this is P of W1 times P of W2 times P of W3 P of Wn. This is a Unigram model, right? So now tell me, which is assigned the highest probability by a Unigram language model? These are the sentences. I like ice cream. Da, go to class daily go to. These are the sequences. Tell me which probability would be highest in case of Unigram language model. Bolo. Any idea?
The probability with the.
Very good. Why?
Yes, sir. Also because it uses the same word again and again. So if I Unigram language model uses when I want to search the first word independent of the previous one.
Not a very right justification. Anyone else
Sir,
wants to try?
I think probability of the will be the highest because the is a stop word, so it will occur a lot of times compared to other words
Yes.
in the corpus. So it will have a very high count.
Yes, exactly. So in case of Unigram language model, as I was mentioning, how to measure this probability of I like the ice cream. It is basically probability of I times probability of like times probability of ice times probability of cream. Similarly, probability of the times the times the times the. Now, how do we measure this? Each of these probabilities is basically count of the word I by n. Right? So automatically, the higher the count in the numerator, the higher the probability. So the word like the is it is called stop word, right? Now, what are the stop words? Stop words are essentially those words which do not stop words. Stop words. Stop words are those words which do not contribute much to the semantics of the sentence, and in general they appear very frequently, a lot of times in a document. So obviously the probability of the word the would be very higher, compared to say the probability of I or the probability of like, right? So automatically this probability is the highest compared to the three others. But in that case, according to your Unigram model, this is the highly probable sentence, a correct sentence, which is wrong. Because da is not a meaningful sentence compared to I like ice cream or go to class daily. These are more meaningful sentences. So therefore you understand, right? If you do not use context, Unigram doesn't use context. Unigram language model doesn't use context. If you do not use context, then you are basically doing wrong. Okay. So as you move from unigram to bigram to trigram to fourgram, you would better off in terms of the probability. Okay. But there's a problem. There's a catch. So can anybody say what's the catch? If I move from say bigram to trigram to 4gram to 5gram language model to 6gram language model, automatically language model would be better. But there is a problem.
So
Zero probability.
Zero probability.
Zero probability.
Zero probability.
Very good. Zero probability. So essentially you are increasing the length of the length of the sequences which is conditioned on. Right? We essentially wanted to reduce this dependency. Therefore, we took all the assumptions. Now, the more we increase this dependency on the context, right? Of course, it is highly likely that your language model would be better, but you will see a lot of zeros, right? We'll see that in the later part. So bigram, now according to Unigram, if you use Shakespeare's corpus, okay, and you try to generate sentences using Unigram language model, you get sentences like this one: fifth and of future doesn't make any sense. Words are okay, but sentence level doesn't make any sense. If you use Bigram model, you see sequence like this would, right? From 500, right? Outside new car, better than Unigram. Okay, better than Unigram. But the problem, as I mentioned, the problem is that dependency on the context would increase, right? Now let's take another example. Let's take another example. The computer, let's take this sentence, the computer which I had just put into the machine room on the 5th floor crashed. So now let's understand, now let's assume that we need to fill up this word. We do not know which word would be appropriate at this position. So this is the context. The computer which I had just put into the machine room on 5th floor dash. Okay. Now see the dependency. This crashed is dependent on the computer, and which I had just put into the machine into the machine room on the 5th floor. This is the modifier of this noun, right? But if you use say 3-gram or 4-gram or bigram language model, what would be the I mean, how do you measure the probability? This would be probability of crashed given 5th floor diagram, right? Or probability of crashed given floor. You see that, you know, this is the probability will be very, very small. So in case of this long-term dependency, Ingram models may not be appropriate. See the point? Okay. So, but since this lecture is more about Ngram, so let's look at other concepts in Ngram. Let's not divert our attention to this long-term dependency, because this is a separate discussion altogether. Now we will look at some of the estimations. Okay, we have already seen how to compute this probability. P of Wi given Wi minus 1 is essentially count of I minus 1 I by count of I. By count of I minus 1, right? So let's take an example. Say this is the corpus. These are 3 sentences. I am Sam, Sam I am, I do not like green eggs and ham, right? These are 3 sentences. And now we are trying to generate sentence. Okay. So in order to do that, we need to compute this probability P of Wi given Wi minus 1. So P of I given S is the start of the sentence. It's just a symbol, a marker, okay, to denote the start of the sentence. So P of I given the start of a sentence is 2 by 3, because out of 3 sentences, in 2 cases I appears after S, after start, right? So 2 by 3. Similarly, say probability of Sam given M is how many times M Sam appears? 1, right? Only 1 times. And how many times the word M appears? Basically 1 and 2, right? So this is 1 by 2 and so on. Similarly for other probabilities. Okay, look at it. If we estimate a probability, if we estimate a bigram language model for the following corpus, right? This is the corpus. What is P of not given do? Bolo. How do we compute this probability?
Sir, is it 0?
0.
Why? This is count of.
Sir, 1.
1. It is 1.
Count
Yeah,
of
1, sir.
do not
Sir, it
by
comes
1 by
out to be 1.
count of do. Right? So count of do not is 1 and count
And
of
do
do is also 1.
Yes, sir.
Right? What is if this is Unigram language model, then what would happen? How to compute this one?
It will be probability of not, sir.
Probability of not,
Not.
right? Which is
1.
1 divided by the number of
1 divided by the number of what?
Words.
Number of words appeared.
There is nothing called words here. Either type or
tokens.
Tokens, sir.
tokens, right? Very good. Very good. So now let's move on. So let's take some examples again. There is this famous corpus called Berkeley Restaurant Project project, where these are basically different restaurants, and there are restaurants and there are reviews of these restaurants. Okay. Can you tell me about your good, etc., you know, mid price, tell me about cheese, etc. Can you give me a list of all kinds of foods and blah, blah, blah. Okay, this is reviews as well as this is a conversation with the outlets. Okay, so if you analyze this corpus, you see that you can draw this kind of matrix. Okay, this is a matrix, a table of vocab cross vocab, number of vocabulary words, number of words in the vocabulary. There are, say, for example, 1, 2, 3, 4, 5, 6, 7, 8 words. I want to eat Chinese food, lunch, spend. These are the unique words in the vocab, and these are again unique words in the vocab. And each of these counts indicates bigram counts. So essentially, this 827 indicates how many times the bigram I want appears in the document. This 5 indicates how many times the bigram I appears in the document, right? 2 indicates how many times want I appears in the document. Okay, so this is the bigram count table. As you see, this is very high because I want is a very popular bigram. Similarly, to eat, very high. Want to, very high, because these bigrams are very popular, right? Chinese food, eat lunch, to spend, these are very famous bigrams. Okay, so this table is given to us. So how do we get the probability of how do we get the bigram probability? We basically need to divide each of these values with the unigram probability, right? Say, for example, in this case, this is count of I want divided by count of I, then we get the bigram probability. Similarly, for this one, we know that the count of the bigram to it is 689. It would be divided by the count of 2, right? And so these are the unigram count we have already calculated. Let's assume. So the count of I is this one, want to eat, etc., etc. So we divide this. We divide this values by these values, and this is your bigram probability matrix. Okay, let me again repeat. This number 0.33, this is count of I want by count of I. Okay, and so on. As you see, one notable conclusion from this table is that most of the entries are 0, which is very obvious because appropriate bigrams, which are meaningful bigrams, are very less compared to the possible bigrams, right? If there are V number of mod V, say you have V vocabulary, which is the set of words, right? Mod V indicates the size of the vocab, right? How many bigrams are possible? How many bigrams are possible out of mod V? Mod V unique words are there. How many bigrams are possible?
Mod V.
Mod V square? Mod V square?
Mod V square.
Why mod V choose 2?
No, sir, mod V square.
Mod V square, because I is also a bigram.
Yes.
Possible bigrams. I am not saying that meaningful bigrams, possible bigrams. Mod V square. So the size of this table would be mod V square, right? And most of the words, most of the entries would be 0. Now let me give you some ideas about the number of zeros. Okay, then I'll come back to. Okay, so that part is missing, but roughly, 99 point. It turned out in case of Shakespeare's corpus, 99.2% of entries in this bigram table is 0. Okay, so think about the sparsity of the matrix. Okay, so now how do we now, let's take a bigram again, bigram language model. How do we estimate this? How do we estimate this sentence? Probability of the sentence, I want English food, start and end marker. It is basically probability of I given start word times probability of want given I times probability of English given word times probability of food given English times probability of end of the sentence given food. Bigram language model, right? Now let's compute these bigrams from the table that we discussed. Okay, so if we take the number probability of one given I, all these numbers, you see that this is going to be 0.000031, the probability of this sentence. Okay, so now let us try to understand what kind of knowledge we are gaining from these probabilities, from these numbers. Okay, so if you look at the table that we discussed, probability of English given want 0.0011, probability of Chinese given want is this, probability of 2 given want is this, eat given 2 is this, food given 2 is 0, 1 given spent is 0, I given S is 0.25. So from these numbers, can we understand the knowledge about the language? Okay, probability. So now let's focus on these two probabilities. Okay, want English and want Chinese. So want Chinese is more probable than want English because we generally love Chinese food than English foods, right? So it basically talks about world's knowledge. Okay, that people generally want more Chinese food than the English food, possibly. Therefore, this probability is high. Okay. What about these two probabilities? 1, 2 and 2 eat. So 1, 2 is 0.66 and 2 eat is 0.28. So this is higher. What does it indicate? It basically indicates some sort of grammar, because 1, 2 is a particular type of grammar, right? 2 generally appears after want, which is very obvious, right? But the word eat generally doesn't appear after 2, right? Now think about this one. Why this is 0? Want given spend. Want doesn't come after spend because both of them are verb, right? So this is called this. So from this probability, you can also guess something about the grammar. This is called structural 0. Due to the structure of the sentence, due to the structure of the grammar, this is 0. But what about this? 2 food. Why this is 0? Is this by mistake?
So maybe
or what?
2 food is not present in the corpus.
No, that is okay. Therefore, it is 0. That I understand. But what does it infer? Can this give you additional information about the language?
So like the grammar is wrong. Maybe that is why.
2 food is a wrong grammar, you are saying?
Yes, sir.
But let me give an example. Let's take this sentence. The right to food and its non-variants is a human right protecting the right for people to feed themselves in dignity. Look at here. 2 food is present.
So maybe it's telling us that we're missing something.
Yes. So basically it is saying that therefore this is called contingent 0. Possibly in the corpus, this kind of evidence is less likely. Okay. So this is structural 0. This is contingent 0.
Sir, How do we know it is a contingent zero or a structural zero?
No. I mean, you do not need to identify which one is structural zero, which one is contingent zero. What I meant to say is that how these different numbers infer different properties of the language.
Okay.
These numbers are not like, I mean, raw numbers per se. These numbers themselves indicate different properties of the sentence, different properties of the language itself.
Okay, thank you, sir.
Okay. So now, as you have seen in this example, in the previous example, that even if I want English food is a valid sentence, the probability is very less. Even the number after decimal point is a lot, right? So you may suffer from underflow when you save this floating point, right? So instead of multiplying all the probabilities, what we do generally, we take the log, right? We take the log, and log of all this multiplication is equivalent to sum of logs, right? So generally we instead of multiplying this, we take the log and then we add all these log probabilities just to avoid the underflow case. And we all know that multiplication is difficult than an addition when we think about hardware requirement and other cases. Therefore, we generally try to avoid multiplication and we use log. So remember, we are interested in relative values, not the absolute values. We are given two sentences. Our task is to understand which sentence is highly likely, which sentence is not, right? So we, instead of looking at the absolute value, we just look at the probability, and we look at the value, and then we can easily compare, right? So taking a log or taking a multiplication of probabilities doesn't matter much. We can take either of this, either log probabilities, sum of log probabilities, or multiplication of probabilities. So I'm now moving to the next part. If you have any query, I can stop for 1 minute and take some questions.
Sir, I have a doubt. Why did we take the sum of log? Why did we take log? I understood why we added.
Anybody wants to respond? Why we take log?
So basically, when we are multiplying all the probabilities, the number will get very small. So to avoid underflow, we are taking log.
So if we take log, what would happen?
So you don't have to multiply, it will get added. The log of that numbers will get added.
That is fine, but
Sir, is it because to normalize the data?
What do you mean by normalization? What do you mean by normalization? So instead of taking log, what else you want to take? You just want to add all the probabilities? I'm asking the question to the guy who has asked the question.
Yes, so why can we not directly add?
If we take the add, then all the concept of probability is gone. We have discussed so many things, chain rules, etc., etc. Then what's the point of joint probability? You know what is joint probability, right? In joint probability, can we add things?
No.
So?
Okay.
The notion should be same in both the cases, right?
Yes, sir.
By taking log, can we say that we get the numbers such that we would be able to handle them?
Of course, this is the reason, but that was not the point. The point was why we are not adding, why we are taking the log, and so remember one thing: when we take the log, we are still multiplying, but due to the virtue of log, due to the property of the log, we are essentially adding. Essentially, we are computing the we are multiplying all the probabilities, but since log has a typical property that when we take the log of a product, it basically sums, it unfolds to sum, right? Therefore, these two things are equivalent. Those things should always be equivalent, right? Multiplication and sum, I mean, raw multiplication and raw summation are not equivalent. Anyway, so moving to the evaluation part, okay? So whenever we design any model, we try to evaluate. How do you know that Unigram language model is better, Bigram language model is bad than the Trigram language model, and so on and so forth, right? So we need to have some ways of evaluating it. You have your own way of evaluating, you have your own language model, I have my own language model. How do you know that my language model is better than yours? Any idea before moving to the answer? Anybody wants to try? How do you evaluate it? How do you evaluate that the sentence generated by a language model is a good sentence or a correct sentence?
So maybe it's like how much time does your
no.
program or condition takes, or how much time does mine?
No. We generally do not consider time complexity as such. What is important is the accuracy.
So most basic would be manual evaluation. I mean,
it is not a scalable approach.
Yeah.
So figuring out whether the wrong sentences are given the lower probability and correct sentences are given higher probability.
So we can evaluate using training data and test data.
Wait a minute. Let me respond. Say, for example, you have two sentences. One is the correct one and the other is the wrong version of the correct one. Okay. You have one language model. Both the language model says that the probability of correct one is higher than the probability of the wrong one. But the magnitude is different. One is saying that this is 0.9 and this is 0.5. Another is saying that this is 0.9 and this is 0.7. Both of them are correct. We are interested in the relative ranking, not the absolute value. Moreover, there are multiple ways to make a sentence wrong. Which one we should choose? Should we change the? Should we manipulate at the grammar level, or should we manipulate at the word level? Should we manipulate at the? Should we drop some words? What is the mechanism? Right. So there are two ways to evaluate any model, right? One is called intrinsic evaluation or internal evaluation. Intrinsic evaluation. In intrinsic evaluation, we okay. So one is called intrinsic evaluation. The other is called extrinsic evaluation or explicit evaluation. Okay. Well, let's discuss what is explicit extrinsic evaluation first. So extrinsic evaluation, what we do is that we take some application. Okay. Extrinsic and intrinsic. In extrinsic evaluation, we take some applications. For example, question answering, summarization, right? Machine translation. Okay. We take some applications where language model is used. Say, for example, machine translation, language model is used. So now let's fix the task. Task is machine translation. Now you have your own language model, say language model A, and I have my language model B, right? So I feed the output of the language model A to the machine translation model. I get the output of machine translation model, right? Similarly, I feed the output of language model B to machine translation model separately, and I get the output. Okay. Then I compare the accuracy of the of these two cases. Let me draw. Say this is the application, machine translation, MT. And this is language model A. This is language model B. First, what I do, I feed the output of the language model A to machine translation and see the accuracy of the machine translation model. Say the accuracy is 0.7. So this, remember, this accuracy is the accuracy of the machine translation model, not the accuracy of language model. Then, independent way, we feed the language model output, language model B output to machine translation and measure the accuracy. So the accuracy is 0.5. We say that language model A is better than language model B. This is explicit, extrinsic. Why? Because an external application is involved here, which is machine translation. It may be summarization, and we do not know, it may happen that for summarization, language model B performs better than language model A. For question answering, language model A performs better than language model B. We do not know, right? So although it is a good way of evaluating a language model, but the problem is that it is dependent on the application, okay? And there is no guarantee that a language model which performs better for one application would also perform similarly for other applications. The second problem in this extrinsic evaluation is that, yes.
So how did we get that accuracy of 0.7 and 0.5 for the machine translation?
Machine translation has a different way of evaluating things. Machine translation, in machine translation, there is a metric called blue score. Okay. So, forget about machine translation. Think about it. So assume that the task is simple sentiment analysis. Feed the output of language model A, and you get some F1 score for sentiment analysis task.
Yes,
right?
sir. Yes.
Because, right, sentiment analysis, you already know that there is a ground truth, and with respect to the ground truth, you measure the accuracy of sentiment analysis, and you get some output, some accuracy. So this, remember, this accuracy is the accuracy of the application, not the accuracy of the language model. But still, you can compare language models because this part is same for both the cases, only this varies. And since with language model A, you got the better accuracy, possibly this is a better model.
Okay, thank you, sir.
Okay. So you understand the problem here. The second problem is it time consuming? Because most of these applications takes a lot of time. So you should not wait till the application ends, right? You may want to, so say you have 1,000 language models, you have to choose one out of them. You can't wait for 4 days for each language model to run on a machine translation application, right? So essentially it would take a lot of time. We possibly need to decide things very quickly. So therefore, this is not a prescribed method, okay? So whatever I just mentioned is written over there. I will share the slides later on. You look at it, right? So the other way of measuring this thing, of measuring the accuracy of a language model, is through intrinsic evaluation. Okay, and there's a metric called perplexity. Okay, what this metric does? This metric is independent of any application. Remember this. Perplexity is a very important metric. It is independent of any application. Although this is not a very useful metric per se, but this is useful to decide which language model to choose at the first place. Okay, what is perplexity? So the intuition behind perplexity is again coming from a game called next word prediction game. Okay, Say for example, I always order pizza with cheese and dash. Okay. If you have different options, so, right, and your language model says that mushroom, the probability that the word mushrooms coming here is 0.1, pepperoni coming here is 0.1, fried rice coming here is 0.001, because it is less likely that fried rice is ordered with cheese, right? And even it is less likely that the word and appears here. This is very, very less likely, right? So your language model should order vocab words in this sequence. Similarly, say I saw a dash. Now anything can come here. It can be chair, table, ball, bat, cricket, football. Anything can come here, right? But if you think of this sentence, the 33rd president of the US was dash, right? It is a very deterministic answer, because you know that the 33rd president of US is possibly John Kennedy, JFK, right? This is a deterministic answer. So whatever answers, possible answers you can return, you for JFK, the probability would be very high compared to the other cases. So this is the idea behind perplexity, and let's try to understand how to compute perplexity. Perplexity is computed in this way. Essentially, perplexity is a probability of a sequence, normalized probability of a sequence. Okay. Say your language model generates this sequence W1, W2, W3, Wn. W1, W2, W3, Wn. Perplexity of this sentence, this sequence, not a sentence, sequence, is the probability of this sequence with some normalization. Okay, so this is the formula: P of W1, W2, Wn to the power minus, remember this minus symbol, minus 1 by n. This is to the power. Okay, so essentially we write in this way. This is 1 by P of W1, W2, W3, Wn to the power 1 by n, right? Which is same as nth power of 1 by this probability, right? Now why this n? What is n here? N is the size of the length of the sequence. So this is again another way of normalizing this, the probability. Another way of penalizing long sentences. Because the more the value of n, you will penalize in some ways, right? We know there are different ways of normalization, right? We can simply measure this probability and divide it by n. This is one of normalization. But perplexity essentially says there is a theory behind this. I'm not going into details of this theory, why to the power n, but y to the power 1 by n, but this is the metric. Now how do we compute this probability? P of W1, W2, W3, Wn. If unigram, then this is simply P of W1 times P of W2 times P of W3, . If bigram, then P of W1 times P of W2 given W1 times P of W3 given W1 given W2, and so on. We already know how to compute it. Now tell me from this formula, what would be the preference? Should we try to increase the perplexity or decrease the perplexity? A good language model should try to increase the value of perplexity or decrease?
Increase.
Decrease, sir.
Huh?
Decrease.
Decrease.
decrease. Why decrease?
Sir, if perplexity is decreased, which means the denominator, the probability value should be high.
Should be high. Very good. So our task would be to increase this probability. If we are trying to increase it, obviously this will decrease. Perplexity would be decreased. So the lower the value of perplexity, the higher the accuracy of the language model. Okay, remember this one.
Sir?
Yeah.
The N there, is it like the unique tokens or just the sequence of all the words?
The sequence of all the words.
Oh.
The length of the sentence, length of the sequence, number of types, number of tokens. Hello, can you hear me?
Yes, sir. Yes, sir. Thank you, sir.
Yeah, thanks. So this is the question. A traffic signal has 3 colors, green, yellow, and red, which appears in the following probabilities. This is the probability. P of green is 2/5, yellow is 1/5, red is 2/5. Using the Unigram language model, Unigram model, what is the perplexity of the sequence green, yellow, and red? Very simple. Tell me. What is the sequence of, what is the perplexity of this sequence? Unigram language model, Unigram model. Bolo? 1 by P of green times P of yellow times P of red.
Sir, 5 by cube root of 4.
Right? And then we know the probabilities. Right? This is the statistics. As I mentioned, lower perplexity is better. This Wall Street Journal corpus, very famous corpus for training. If you use Unigram language model, you get a perplexity of 962. If you use Bigram language model, perplexity would be 170. If you use Trigram language model, it is 109. So as you see, Trigram language model is better than Bigram or Unigram, right? So now moving to the last part of the discussion. Let me take a very quick break. If you have any query, please let me know. If you
Sir, I have a doubt from the previous part. You were talking about the Bigram matrix, no, sir? Is that the co-occurrence matrix?
Yes, yes.
But aren't we, I mean, in co-occurrence matrix, isn't that supposed to be symmetrical, sir? But that wasn't symmetrical.
No, co-occurrence matrix is not symmetrical. No, not at all.
Okay.
I1 is not equivalent to 1 tie.
Yeah, but we had told that it's like considering the window size, so it's equal. So it's not the case.
That is different issue. That's a different issue. So co-occurrence matrix can be computed in many ways.
Okay.
Right? If you ignore the sequence, if you ignore the ordering,
yes, sir.
If you ignore the ordering, then it's a symmetric matrix.
Okay, sir. Thank you, sir.
Any other query? How many of you are still alive? I can't see faces now. Okay, cool. Okay, so moving to the next part. It's a very simple concept, right? I'm not discussing any complex equations, etc. So hope things are easy to understand, right? And this is the first day I think the first day of this NLP lecture. Yesterday was a mathematics lecture, right? The first day.
Yes, sir.
Yes, sir.
Lecture, I really do not want to make you scared. So don't be scared. Okay, so now moving to the last part, this would be slightly mathematical. Okay, don't worry. I mean, I'll try to explain it as simply as possible. So This is about counting zeros. Okay, you remember when you computed when you discussed about the probabilities of the bigram, we computed the count of the bigram by the count of the unigram, right? We also discussed that with the increase of the context, the length of the context, most of the cases you encounter zero, right? Reasonable cases you encounter zero. How to avoid those cases? How to tackle this problem? Okay, so let's take an example, and this discussion comes from, again, Shannon's. There's something called Shannon's visualization method. This Shannon is same as entropy, Shannon's entropy. Okay, so there's a famous story that if you really want to admire someone in the field of computer science or electronics, whatever, you should admire Shannon. You should take a picture of Shannon and paste it on your wall and possibly admire him every day, because the kind of contribution that he has in areas including electrical, electronics, computer science, possibly he should be called as the inventor of the field computer science, electronics. Anyways, so this is again coming from the concept of Shannon's visualization method. Okay, and the idea is again next word prediction. Okay, so you choose. So how do you generate a sentence, right? How do you generate a sentence? So using a language model, say you have a Bigram language model, you look at your training set and see what is going to be the first word in a sentence, right? So you look at all the cases in your training sample and see how many times which word comes at the beginning, and you possibly observe that the word I is highly likely to come first. So now once we get I, what is going to the next word, right? Possibly I want. Given I want, what is going to the next word? Want to, right? Given I want to eat. This is Bigram language model, remember this. To eat, then eat Chinese, then Chinese food. Simply looks like this. Okay, so right, if you use Unigram language model, as we have already seen, sentence that doesn't make much sense, right? For example, here, to him, swallowed, doesn't make any sense. If you use Bigram, I rest, I confess, still it is okay. All sorts. If you use trigram, then indeed the Duke, this shall forbid, it doesn't make any sense. But indeed the Duke sounds like a Shakespeare sentence, right? Before the sadness, right? Sounds like a good sentence, good sequence. If you use quadrigram, fourgram, sentence like I can't be but so, it looks like a Shakespeare sentence, right? So essentially, as you increase your n-gram from unigram to bigram to trigram, your sentence sound like a meaningful sentence. Okay, but the problem is this one. As I was mentioning, 99.96% of words, possible bigrams are never seen before. Okay, how do you handle these cases? So, and you remember this matrix, right? We discussed most of the entries are zero. Okay. So what we do here, so now let's again take some examples. Say in your training set, the sequence like denied the allegation, denied the report, denied the claims, denied the request, these phrases are there. But denied the offer, although this is a meaningful phrase, but since this has not appeared in the document, the probability would be zero, right? So in the test set, if we have a sequence like this, denied the offer or denied the loan, your language model will say that this is zero. although these sequences are meaningful sequences, right? So how do we overcome this? There's something there's a method called smoothing. Okay, smoothing. Mitigate zeros in your in the matrix, in the bigram matrix or trigram matrix or n-gram matrix. Okay. So what is the basic idea behind smoothing? The idea behind smoothing is that we look at the probabilities of individual words, right? We look at the probabilities, say in case of bigram assumption, we look at the bigram distribution, then we steal some distribution, we steal some probabilities. We take some probabilities from the seen bigram and give those probabilities to the unseen bigram. What does it mean? Okay, say given that denied the, this is the context, say allegation appears 3 times, report appears 2 times, claims appears 1 time, request appear 1 time, right? This is 3. So these are words and these are counts, simply counts. Okay, now from this count histogram, you can make a probability histogram, right? Dividing it by the, I should not use the term histogram here, but you divide it by the unigram, and now this is here, these are x-axis is words and y-axis is the bigram probability P of W2 given W1. Okay, and you see here that attack, man, outcome, denied the attack, denied the man, denied the outcome. These probabilities are counts as 0. So what you do here, you take something from here, and give them, distribute them to those which do not have any value. Okay, take some money from rich and distribute it to poor. This is the idea. Okay, but in order to do that, always remember that it should follow, it should not violate the probability rules. For example, the sum of all the probabilities given the word denied the should be 1, and so on and so forth. It should not violate the probability rules, right? The sum should not be greater than 1, and so on and so forth. Okay, so the basic smoothing technique is called, the simple one is called advanced smoothing, right? It is also called Laplace smoothing. Okay, so what is the idea? So the idea is that, so this is the concept behind advanced smoothing. So idea is that you pretend we saw each word 1 more time than we did. So we pretend that, right? We pretend that we saw the words 1 more time than we did in real life. Means if the bigram appears 1 times, we pretend that we have seen this bigram 2 times. If the word appears 0 times, we assume that it appears 1 time. This is the idea. Okay, so essentially we are saying that we just add 1 to all the counts in that matrix, bigram matrix, right? So now the probability of this bigram is essentially count of this bigram plus 1 by, this is very important. So when we say that probability of W2 given W1 is count of W1 W2 by count of W1, we are adding 1 here. We are adding 1 here, assuming that this bigram appears 1 more time than the reality. Okay, if we add 1 here, then we also need to change the denominator. Why? Because we know that the sum of all Wi's given W1 should be 1. Right? Now, for all i's, what are these i's? These are all the vocab words, right? You have W1, W2, dot, 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 Wn. You basically mean to say that probability of W1 given W1 plus probability of W2 given W1 dot, 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 probability of Wn given W1 should be 1, right? So this rule should not be violated. So when we add 1 to the numerator, you should also add something to the denominator. So how much do we need to add here? What quantity we need to add here?
So the number of words, like, because we added 1 to
number of words in the
vocabulary.
There is nothing called word. Please answer in terms of types or tokens. Number of types or number of tokens?
The number of types.
Number of types?
Mm.
You mean the size of the vocab?
Yes, yes.
Which is what? Which is mod V? Right? Very good. So this is going to be mod V. Why? Because remember, for each of these terms, we are adding 1 to the denominator. So automatically, mod V times we are adding 1. Right? Mod V times we are adding 1 to the denominator, to the numerator. So automatically we need to balance it, normalize it by adding mod V to the denominator. Okay. So this is the formula now. The modified formula with add 1 smoothing. Okay. Now instead of adding 1, you can also add alpha. This alpha can be any value, 0.5, 2, 3, anything. If you add alpha here, then this is going to be, this part is going to be
V alpha. V alpha.
Mod of V alpha, right? Okay, so, okay, all right. So this is the same matrix that I showed earlier. Now I replaced all zeros by ones. All these blue colored numbers are ones. Okay, earlier all these blue numbers were 0. Okay, and all these counts are now increased by 1. Other counts are increased by 1. Earlier it was 5, now it is 6. Earlier it was 827, now it is 828. Okay, so this is the modified smooth count, bigram count. So now from that we can easily compute the probability using this formula, right? So this is the bigram probability matrix. Okay, you see none of these entries are 0. You gave some non-negligible probabilities here and there, right? But interesting fact is that you know, using this, what do I say? Using this modified probability, if we re-estimate, if we recalculate the bigram probability, bigram count again, okay, the bigram count table would look like this, and this is the formula. This is the estimated, this is the new count divided by, right, this is the new count. So C star W2, W1, W2 by C W1 is C W, W1, W2 plus 1 by plus V. Okay, if we re-estimate, if we recompute the bigram count again, it would look like this. Now, interesting point to note is that This was the previous table. This is the new table after smoothing. This is count, not the probability. Earlier it was 827. Now this is 527. Earlier it was 5. Now this is 3.8. Earlier it was 608. Now this is 238. Huge drop. Huge drop in count. Earlier it was 689. Now this is 430. Okay. What does it indicate? Why it is so? Why so much drop? There are 99.96% zeros. Okay. So all these 99% zeros, you are giving one count. So automatically you are basically stealing a lot of wealth from the rich. Okay. So
I have a question. How did we get these counts? Didn't we just add 1 to all the counts in the Bigram table?
We added 1. Well, so this is the smooth. This is the what should I say? This is the this. So this table, in this table you have just bluntly added 1, right? But remember this: when you add 1, you are overestimating the number of tokens, number of types in the corpus. You need to readjust them, right? You need to readjust them. So the sum of all these numbers should be the actual bigrams which is present. But if you sum all these numbers from this table, it will overestimate the number. So this is just an auxiliary table to compute this probability. Now from this probability, when you get this matrix, if you sum all the bigrams, then you are actually taking care of the actual number present in the corpus. You can think of the other table just auxiliary table to compute this probability. You see the point?
So we first add 1 and we get the auxiliary table, and then we compute the probability, and then we compute.
So you first add 1, you get the overestimated the auxiliary table. From the auxiliary table, you compute the smooth probability, smooth version of the probability. From smooth version of the probability, because when you are adding 1, you are not discounting anything. You are not discounting anything from any counts, but essentially you need to discount something from the existing counts. Right? You are just blindly adding 1. You are computing the smooth probability. Now this smooth probability takes care of the fact that the sum of the probability is 1. The count is maintained in a proper way. Now from this P star, which is the smooth probability, you are re-estimating the count again. Now in this re-estimation, in this recomputation, you take care of the fact that some numbers are stolen from the existing numbers. Some probability mass is stolen from the existing probabilities. Therefore, this number is less. These numbers are less.
Okay, got it.
Got it?
Yeah, thank you.
Good. So, okay. So advanced smoothing, right? We know how to compute it. Some cases, although advanced smoothing is a very simple idea, and it is used for cases like text classification, etc. For language model, we generally do not use advanced smoothing. We use more sophisticated smoothing techniques, right? For example, we use something called back off technique for smoothing. Okay. What is back off? So the idea being back off is that, say you are doing you are considering trigram language model, right? So if you do not get much evidence about trigram in your corpus, you back off and you go to the bigram. If you do not get much evidence about the bigram, you back off and you go to the unigram, and so on. Let me give an example. So For example, say this is a this is diagram language model, right? So you want to predict Wn given Wn minus 1, Wn minus 2, right? So essentially count of Wn minus 2, Wn minus 1, Wn by count of Wn minus 2, Wn minus 1. I'm not using smoothing. I'm not using advanced smoothing. I'm using back off technique, right? So if this counts, if one of these count is 0, right? You back off and you move to the bigram estimation. So it was trigram. You back off and move to the bigram. So now look at here. This is bigram. This is unigram. Again, you back off and take unigram. So essentially, you are taking trigram, bigram, unigram with some weights. So lambda 1 is a weight, a value. How much you want to give weight to trigram estimation? How much you want to give weight to bigram estimation? And so on. Okay, so that all these lambda should be 1. So you back off and you use bigram, you back off, you use unigram, and so on. This is back off, right? Now in back off, what we do? We compute them independently. What I mean to say is that in order to compute the probability of Wn given Wn minus 2, Wn minus 1, if you see that the count of the trigram estimation, I mean this count, if this count is 0, we back off and we count the bigram estimation. So basically count Wn minus 1, Wn by count of Wn minus 1. If this is still 0, then we use count of Wn minus 1, right, by n. This is back off. But when we consider all these things together with some weights, this is interpolation. So the difference between interpolation and back off is that in interpolation, you are considering all the probabilities with some weights, right? In back off, you consider one probability at a time. If you are done with this, you ignore these two things. If you are not done with this, you ignore this. You consider this one. If you see that still it is 0, you consider this one independently. Okay, not a combined approach. So I do not have much time. I wanted to discuss there is a slightly advanced smoothing technique called good Turing method. I wanted to discuss this one. So Sandeep, are you there?
Yes, I am there.
Should I continue or should I stop here? I can possibly.
No. You can finish the session. We will extend the end zone.
Okay. Cool. So now moving to more advanced kind of techniques, but before that, let's understand another important concept: how to handle unknown words. Right? Those words which do not appear in the vocabulary in your training set, right? But still meaningful words. Now, in the advent of this social media, you see a lot of new words like LOL, right? Which is not a dictionary word, but still, useful word. How do we handle such unknown words? Okay. How do we compute unknown words probability? Okay. In case of, say, in a test set, you see a sentence like OMG, You are mad. Right? So your task is to measure the probability of this sentence, right? You compute it in this way: probability of OMG, say unigram, simple unigram, probability of U and dot dot dot. So this is going to be 0. If this is 0, then entire probability is 0. Right? How do you do that? How do you handle this situation? Any idea? Do not look at the slide. Tell me. How do we handle unknown words which are not part of training sets but appear in a test set? Guys, any idea? Anybody wants to have a try? Give a try.
Sir, maybe you can, I mean, for the first time you encounter, you can, to make it like significant, you can have some smoothing, and then you can add those words that you've not seen to the training set.
You are exactly hinting upon the wrong place. So try to understand the difference between training and smoothing and unknown words. Smoothing, we do smoothing during the training phase. In the training phase, we need to do all this computation, all this bigram, unigram computation. In the test set, in the testing phase, we can't do any smoothing. We just take the numbers from the table, from the bigram table, bigram probability table, and then we multiply. Whatever smoothing you want, you do it in the, you need to do it during the training.
So, sir, the words that we have not seen, we can add it to the training data, then train the model again.
No, that's not a feasible, that's not a good idea. If you do that, you need to recompute things again and again. If you add one new word in your training set, we need to recompute all other probabilities. Right? So but again, it is not a feasible solution, because you encounter many words, many such unknown words at multiple times. Does it mean that you always add them in a training set and recompute things again and again? Not possible.
Okay, sir.
Right? Any idea? Well, so what we do in this case is that we consider some of the words in the training set as unknown words. Okay, so remember the table that we discussed, that was vocab cross vocab table, right? So all the words which are present in the vocabulary, right, constitute the rows, similarly columns, right? So now and how do we create this vocab? Vocab is nothing but a set of words, number of unique tokens, right? So vocab creation is up to our hand. What we do is that we consider some of the words whose frequency is very less in the training set as unknown words. Okay, some of the words whose frequency is say below 5, count is below 5, as unknown words, right? And we replace those words by a token called UNK. Now UNK, you add this new token to the vocab, right? So in your table here, one entry would be UNK Ank. This is unknown, UNK Ank. And you do the same estimation. So let me repeat. In your training set, you identify some of the words which are less frequent. You replace those words by the unique token called UNK, assuming that they are unknown words, and then you compute the same thing. So whenever you encounter a new word in a test set, you take the probability corresponding to the UNK and recompute. right? So OMG, P of OMG would be count of UNK by N. Okay, clear? Is this clear?
Yes.
Yes, sir.
That means for every unknown, it is considering same.
Yes. Yes. Okay. There is another smoothing technique. It's called stupid back off. There's another smoothing technique which turned out to be very useful in web corpus, which is a huge corpus of n-grams, right? In stupid back off, the idea is that you first count. Say this is the score. Score of here we use the term score, not the probability, right? So in stupid back off, what do? We first count n-gram wise, the way we do n-gram. If we see that this is 0, we back off and we use n-1 gram, right? So as you see here, the condition is last k minus 1 words, but here the condition is last k minus 2 words, and it is multiplied by some number. See, why 0.4? I do not know. They in their paper they empirically showed that 0.4 works better than others. Okay. It turned out to be very useful. Now if this is still 0, you again back off and go to k minus 3 gram. Similarly, k minus 4, k minus 5, right? Okay. So I am also exhausted. A good Turing, there is a technique called good Turing method. Okay, let me discuss it in tomorrow's session. Okay, so tomorrow I have another session on parsing. I will go through this good Turing method quickly first, and then finish this part. It has 3-4 more slides. Okay, I'll finish this part tomorrow, and I will then start the next chapter. Parsing. Okay.
So, Professor, shall we start hands-on session? I mean,
yes.
Sonal is ready. Okay,
yes.
Okay. So within, I mean, we took 10 minutes break.
Yeah.
I guess. I mean, each okay, and 10-15 minutes we will start the hands-on session.
In between, guys, if you have any query, unmute and ask. How many of you have already encountered all the concepts that I have discussed earlier today?
I know the theory, sir, but not actually where it is used or how to use them.
Who are you? May I know your name?
Sriparna.
So I hope that some of the things are useful to you, and I also hope that you understood some of the concepts.
Yes.
ठीक है? Any query? Any further query? How many of you are PhD students? Any PhD student here?
Yes, sir.
Unmute. Munali?
Yes, sir.
No.
Yes.
Okay, you are PhD student. Where from you? You are from?
Yes, sir.
Yes, PhD from North Maharashtra University, Jalgaon.
Subarna?
Yes, sir.
You are also PhD student?
Yes, sir. I'm also PhD student.
From?
I'm also from Jalgaon, Maharashtra, sir.
Okay.
I'm also a PhD student, sir.
Your name?
Ashima.
You're from?
From Delhi Technological University.
Okay.
Same here, sir.
Okay. What's your name?
My name is Lahori, but I am a PhD student in linguistics from Jadavpur University.
Oh, okay.
I'm also a PhD student, sir.
Okay, your name?
My name is Arna Devi. I'm from
How many of you are masters? Masters?
And I'm an
MS,
MTech
MTech.
first year student.
From?
Jaini from IIT Hyderabad.
IIT Hyderabad. MTech first year. CS?
Yes, sir.
Okay.
Sir,
Who else?
MCA second year from IGDTU.
IGDTU. Who else?
I'm Meena from Cochin University.
There should be a introductory session, no? From Cochin University. Okay.
Yes, sir. Myself, Vishnu Prabha from Cochin University.
Okay. Great. You're all master student?
No, PhD student.
PhD. Any undergrad students here?
Yes, sir.
The rest are undergrads?
Yes, sir.
Yes, sir.
Okay. So, Sandeep, you need 5-10 more minutes.
Yes, so actually, I mean, we should give break around 10 minutes. So around 5:30, we will start the laboratory session. So 5:30 to 6:30, I guess.
So can I have a very quick introductory session if possible, one by one?
Yes.
Meanwhile, they can set up their computer and other things.
Okay.
So
Okay, so
what
what
do we require for the practical session? Is
Jupyter
there
notebook.
Okay, only Jupyter notebook. Okay. Collab. Okay.
This is going to be very simple. We'll have some Ingram language model experiment. He will compute perplexity. Simple.
So, sir, Sonal, are you there? Sonal?
Yes, sir, I'm there.
Okay, okay. So Professor, what I mean, shall we start or we will? I mean, I am okay.
See, we will start at 5:30, right?
I mean, according to you, I mean, if you want 5:30,
Hold on. We'll start at 5:30.
Okay.
And
Yeah.
sir, actually, I wanted to say that I have lost the host controls because my internet connection was not stable. So I think you are host. So can you please pass?
1 minute, 1 minute.
Sandeep can.
Yes, I will take care. 1 minute, just hold.
Yeah.
Can I have a very quick introduction to all the participants? Let me start. Is Meena Padnekar, right? Are you there? I can't hear you. You're on mute, Meena. Yes.
Okay, can you hear me now?
Yep.
Okay, I'm from Cochin University. I'm doing my MTech in Computer and Information Science.
Great. Rushpa Patil. Pushpa Patil.
Yes, sir. Myself, Pushpa. I'm a PhD student from North Maharashtra University, Jalgaon.
Okay. Asima, thank you.
Yes, sir. I'm also a PhD student. I'm pursuing my PhD from Delhi Technological University, and I've just submitted my PhD.
Okay.
Yeah.
Great. Sudhanshu.
Sir, good evening. Sir, hello.
Hi.
Yes, sir. Sir, I am PhD student from NIT Rourkela. This year only I joined. I was there in DRDO as a research fellow, and now I left and I joined this year only.
Who is your advisor?
Sir, Vidyut Kumar Patra, sir.
Yeah. Say hi to Vidyut. He knows me very well.
Yes, sir. He told me that his friend is taking.
Yeah. Suparna.
Sir, I'm also a PhD student from North Maharashtra University, Jalgaon, Maharashtra.
Okay. Aruna Devi.
I'm Arna Devi. I'm finally a PhD student doing my PhD in Sultan Qaboos University, Oman.
ऐश्वर्या
पाणी तरी म्हणा जाऊ दे छान मस्त गेले म्हणा बढिया
त्याला बॉर्डर नाही करायची का
झालं
ऐश्वर्या
Yes, sir. I am Aishwarya Matthew. I'm doing my undergrad. I'm in final year currently from FCRIT Navi Mumbai.
Okay, great. I can't see the other names actually. I'm sorry. Sibani Patil.
Hello, sir. I'm Shivani. I'm final year BTech student at Cummins College, Pune.
काय झालं
Okay. Someone's
पप्पांना सांगून जा जे करतोयस ते
mic is unmute. Can you please mute it? Then Lehar Vandari.
Yes, sir. I'm actually working right now. I'm a software engineer at Expedia, and I did my undergrad. I did my undergrad from NSIT Delhi.
Okay. Sangeeta.
Hello, sir. I'm Sangeeta from PhD College of Technology, Coimbatore, and I'm a third year student of 5 years integrated MSc course.
Okay, great. Anushka. Anushka doesn't seem to be here. Aditi.
Hello, sir. Myself Aditi. I am a PhD student from IISER Bhopal.
Okay. IISER Bhopal.
Yes.
Which department?
Department of Electrical Engineering and Computer Science.
Okay. Ananya?
Hello, sir. Ananya
Hi.
here.
Mm-hmm.
I am from PhD College of Tech, and I'm third year student of integrated master's course in third tech.
Okay. Sarvari?
Hello, I am Sharvari. I study in BITS Pilani. I am currently enrolled in an integrated course in which I have two majors, MSc Physics and BE Computer Science.
BITS Pilani, which campus?
Goa campus.
Goa campus. I visited Goa campus last year. CS department. Kirupa?
Hello, sir. Myself, Kirupa. I'm a theoretical computer science student at PhD College of Technology.
Jaini?
Hello, sir. I'm an MTech CSE first year student at IIT Hyderabad. I did my BTech in electronics and I was interested in computer science, so I decided to do an MTech in CS.
Okay, great. Vidya. Divya, sorry. Divya. Liji SK.
Sir, I am PhD student from Calicut University from Kerala.
Okay. Okay. You're
My research topic is Malayalam question answering system.
Oh, great. It's good that people are working on low research language. Very good.
Thank you, sir. I have done MPhil in the same area.
Okay.
It is syntactic level question answering system.
Okay. Cool. Suman Mitra.
Actually, Professor, he is our Dean, DAICT Dean. He joined.
Oh,
Suman, sir.
okay. Oh,
I'm just listening to you.
Hi, Dr. Suman. Hi, Dr. Suman. Sorry.
No, it's okay.
Sorry.
Actually, he is from machine learning, and he also one of the speaker for embedding part. Embedding part. Okay.
Great.
Please go ahead, Professor. Please go ahead.
Lahori, no, I am almost done. You will start at 5:30. Lahori.
Yes.
Yes, sir. I am from Jadavpur University. I am a PhD student in linguistics.
Okay. When I was doing my master's in Jadavpur, I used to visit linguistics department quite often to learn German language. So in one of the projects, we needed to learn this language. We often, I took part of some of the discussions.
Okay. Sir, my PhD work is mostly on speech processing
And I work with Shamol sir from IIT
Shamol.
Kharagpur as well. Yes.
Okay.
Thank you, sir.
Great. Thanks. Aditi? Arushi?
Hello, sir. I'm
Hi.
Arushi. I'm doing second year MCA from Indira Gandhi Delhi Technical University.
Who else are left? Sorry, I'm very bad in Zoom. I generally use Google Meet. Who else is left? Can you please unmute one by one?
I mean, there are
Good evening, sir.
Yes, hi.
Myself, Sonia. I am PG student from LPU.
Okay, great.
Good
Next.
evening,
Hi.
sir. My name is Shruti, and I'm a BTech CSE student from Banasri Vidyapeeth, third year.
Okay. Where it is?
Sorry,
Your
sir.
institute?
Banasri Vidyapeeth,
Where is it located?
Rajasthan.
Rajasthan. Okay.
Near Jaipur. Yes, sir.
Sir, I'm Sumana.
Hi,
And
Sumana.
I'm from IIT Goa, CSE third year undergrad.
IIT Goa. Okay, CSE third year. Okay.
Hello, sir. I am Sarla More. I am from Central University, Sagar. I am doing PhD in operating systems.
Okay. Great.
Hello, sir. I am Ritika Dhiman. I am currently a final year student at Punjab University. And last year, I attended an ACM Winter School on hybrid cloud at IIC Bangalore.
Great.
Yeah.
Great.
Thank you.
Okay. Next.
Hello, sir. This
Hi.
is Sriparna, and I'm from PhD College of Technology. I'm doing my third year in 5 years integrated masters.
Okay. Next.
Hello, sir.
Hi.
Sir, I'm Aishwarya. I also belong to PhD College of Technology. I'm doing my master's in theoretical computer science.
Okay.
Hi, sir. I'm Chaitra Bhatt. I'm currently an undergraduate student from International Institute of Information Technology, Pune. And I'm doing computer engineering.
Great. Who else?
Good evening, sir.
Hi. Good evening.
Ramya Panikar. I'm from North Maharashtra University, Jalgaon. I'm doing PhD in Hindi sentiment analysis.
Okay.
Thank you.
Good. Which corpus you are using?
Actually, I have started my work just now, and actually, I'm building my own corpus.
Okay. Next. Thank you. We have 3 minutes left.
Hello, sir.
We need to wrap up by 5:30. Otherwise,
I'm Kavita Patel.
Sandeep is going to beat me.
Hello.
Yeah. Hi.
Hello.
Go on. Hello.
Hello, sir.
Yes,
I'm
yes.
Kavita Patel from North
Go on.
Maharashtra University, Jalgaon. I'm doing PhD in spell checker for Marathi language.
Oh, very good. Okay.
Hello, sir. I'm Shalaka Thorat from International Institute of Information Technology, Pune, and I'm an undergrad student, BIT. So last year.
This is IIIT Pune, na?
Yes.
This is also International Institute. I mean, same as IIIT Hyderabad, right?
Yeah.
Okay. Good. Next.
Sir, I'm Srinidhi from PhD College of Technology. I'm doing integrated MSc in theoretical computer science.
Okay. Next.
Sir, hello, sir. I'm Srinidhi. I'm also from PhD College of Technology. I'm in third year integrated masters in data science.
You're also Srinidhi?
Yes, sir.
Now, look, this is a very important problem in NLP, right? This is called named entity disambiguation. Okay. Now, given similar words, how do you disambiguate that this refers to this Srinidhi, this refers to this Srinidhi, right? And this is a very interesting problem. And this is an unsolved problem for low resource languages, by the way. Still, this is an unsolved problem for rich resource languages like English, Chinese. This is almost solved, but for low resource languages, not solved yet. Next.
Okay. Hi, Professor Tanmoy.
Hi.
I did my bachelor's from IIIT Delhi, and I took one course under your guidance as well. And then I pursued my master's from University of California, Berkeley.
Wow.
Yeah.
What's your name?
Rashmi Nagpal, Professor.
Rashmi, you attended my course.
Yeah, Professor.
Which course?
NLP.
Oh, Rashmi Nagpal, I remember. I now remember your face. Very good. Great to see that you are where you are in University of California.
Yes, Professor. And at the moment, I'm
Very
looking
good.
for the PhD and research assistantship roles.
Okay. Okay. Good. Good.
Thank
Great.
you.
Thank
Great
you.
to see you here
Yeah.
as
Yeah.
well.
Same here. Next. We are done. Okay. So Sandeep, we are done. So
Okay.
you can possibly start the next session.
Okay. So just one advice to all of you, that please follow Twitter handle of Professor Tanmoy Chakraborty or his lab and his
That is not
Google
needed.
Scholar.
That is not needed. But if you think
Google
that
Scholar.
updates are important, some of the
Yes,
updates are
so
important, you can.
They will get to know what is happening. I mean, what you are doing, so that that will help him to learn actually what the people are doing right now.
Thanks, Sandeep.
And Google Scholar is, I guess, better way, because I follow same thing. Who is doing good? So the Google Scholar is the best way to get updated. Thank you.
Thank you.
So,
Sandeep,
Sonal,
do you also want me to stay here, or I can leave?
No, you can leave. I mean, if you want to leave, me and Sonal will manage the session.
Okay, so I am leaving now. I will.
Sandeep, I am also leaving. Sandeep.
Okay.
I'm also
Thank you,
leaving.
sir. Thank you. Okay.
So we'll join again tomorrow at 3 p.m. Okay. Bye bye.
Okay. Thank you. Thank you, Professor.
Thank you, sir.
Thank you.
Okay. Thank you. Sonal, you can start. I mean, you are host. You can start the session.
I'm the host. Yeah, I'm the starting. So, hello everyone, I'm Sonal Mishra and I'm currently pursuing a master's of second year from DAIICT in machine learning. So right now I'm your TA for this language modeling part, and there are a few experiments that I'll give you and you have to perform that and you have to submit the assignment. So I'm just sharing my screen and then I'll just notify you. Okay, so is my screen visible?
Yes.
Yes, it is.
Yeah, okay. So the thing is, since I thought that it is just the beginning of NLP sessions, so I thought that let's keep the practicals quite simple. And the thing I want to tell apart from the fact is we have to, I mean, you guys have to submit this assignment, like just a small part of assignment, which is a trigram implementation. I'll be sharing the code as well with you guys by today evening or maybe by tomorrow morning, so that you get a clear idea. Right now, I'll just explain you which packages that you have to use as well. If you want me, like if you don't want to use packages like NLTK, just I before that, I just want to ask you, like, I mean, how many of you are familiar with the NLTK packages or using Python for this data, I mean, for this NLTK purpose?
I know Python. NLTK I have very less familiarity.
Okay, so like, I mean, so I should, I mean, I'm just starting from the very basics. Okay.
Yeah.
So yeah. Okay. So before starting this thing, let me tell you. Okay. So the very first thing which you have to do is, since sir has taught about the n-grams part, so it's better if we start by visualizing the things. So this is a small practical that I have created, and yeah, just a second, I'll just yes, okay. So now before starting with n-grams basically takes a sentence or a group of sentence and it divides them into tokens. Okay, so if this is the sentence which is given to you all, and if you want to divide it into tokens format or like in bigrams or trigrams, so Python has given us the, I mean, the library to do that with ease. Like you have to just import few libraries from Python, which is NLTK. NLTK is basically used for just natural language processing or NLP, like any kind of things that you do, be it word tokenizing or n-grams or anything related to NLP can be easily found in NLTK packages.
So the very first thing which we will do is, I'll just demonstrate is, initially you are given a text. Suppose this is the sentence, and then you have to tokenize it, because the reason why we tokenize every text is we need to develop, you can't take the entire sentences in just a single go. Moreover, in case of NLP, we deal with words so that we can understand what we actually want to achieve, or what is the context of the thing. So as you know that bigrams or trigrams or fourgrams are mainly used for like analyzing the thing, like analyzing the word that would come next. So here we take like here, I'll just give you guys a demonstration. Like this is bigram. So to use bigram, what you have to do is you just have to call ngrams, like ngrams function, and you have to pass token. Token is nothing but the word that you just got after tokenizing. So if you want, then I can show this step by step. Like, is it so? Should I print every sentence and show you guys, or is it okay?
It is okay.
Okay, so using the tokens, you have to using the tokenize word tokenize function of NLTK, you have to tokenize each of the text, and then you have to pass that thing on ngrams function, which is basically used to divide the tokens into bigrams, trigrams, fourgrams, and fivegrams. Okay, so here what we do is we pass the token as well as the number in which we want to divide. So here are the examples. Like if you divide, and there is another thing called counter, which stores the bigram. Like for example, here our sentence is, hello everyone, we can start the assignment. So in case of bigram, the next consecutive words are taken into consideration. Like for example, hello everyone is taken. Then the second word would be everyone we. Then the third would be we can. So this is what bigram does. Then we have trigrams. So in case of trigrams, we have 3 consecutive words, as sir said. Then we have fourgrams. In case of fourgrams, we have 4 consecutive words. And in case of fivegrams, we have 5 consecutive words. Now, since like in case of NLP, we all know that we have to handle real data sets. So because of that, I have taken a movie review data set from which it is Kaggle's data set, and it is a part of stands for data set. So this is a real movie data set which I have taken into consideration. So this has basically 4 columns, in which just one column is important, which is text, because we will be using text as the main thing to tokenize. Okay, the rest of the columns you can ignore, it is not important. So in case of and before doing that, you have to do data pre-processing. This is important because we don't need punctuations, or we don't need stop words, obviously, but I have taken into consideration stop words because there is no point in removing them in case of bigrams and trigrams. So I have not removed stop words. However, I have removed the punctuation marks, and I have cleaned the data. Like I have converted the entire thing into lower case. So in this case, like as you can see that there is a bracket which is removed in the next word, which is sentence clean. You just have to use a replace thing, which replaces every bracket, comma, or anything, like whatever you want to replace over here, you can write it and it gets replaced. Like the punctuation marks gets replaced and the entire sentence gets converted into lower case. So it would be helpful to you all. And since the data is really huge, so even during assignments, I would advise you guys to just take top 1000 or top 2000 rows, because the data set size is something around 67,000. So it's not necessary. Moreover, it will consume a lot of time. So here just top 4 rows I have printed so that like we get a clear idea about how the data set is and how we are going to work. And after cleaning this sentence, we are going to use sentence clean as as the text for classification purpose. Now trigram is something which I have given you guys for assignment purpose. So I'll be demonstrating bigram using NLTK library. So the very first thing which we have to do is we have to import the libraries. The first library is dictionaries one, so that you can build the dictionary and it would be represented in a way such that like you can visualize the dictionary. I can just tell you, like for example, a word would be there and the count would be there. as you know that we over here we have to find the probability so that we can know which word would be coming next. So for that purpose, we need to keep a count about how many times a word has repeated. Okay, and in case of bigram, when we talk about bigrams, you will be given a word. Like for example, in this case or in this sentence, just a second. Yeah. So in this sentence, suppose you are given a word called starters. So what is the probability that it would come after that? Or what is the probability that was would come? So that's why we would be using dictionary, because it would be helpful for us, like for counting purposes. So what I have done is I've just taken the sentence. So yeah. And are you guys familiar with data frames?
Didi, I have a question.
Yeah.
Yes. Can you explain lambda here in the default dictionary?
Yeah, so in lambda is just a function. Like whenever you want to define, like in case of C, you have inline function. So in case of Python, even you have an inline function. And we say it, when you don't want to write an entire function, like using def and keywords and everything, you simply use lambda. So lambda is just a function which is in just a single line. Like for example, default in like the default dictionary or the default thing, I have given over here lambda colon default dictionary lambda colon. I have done this because like as you can see, like see over here you have this is just a small representation of the dictionary. So here I have created, like I needed that what is the probability that after apart as will appear. So you can tally the lambda thing. Like for example, the word over here is apart, and after that you have a column where like it is kind of dictionary inside dictionary, and lambda is an inline function which is used to depict, like if you don't want to write an entire function, because in this case we won't need the entire definition of function. So this is the reason I have used lambda. Like it would be short. You can even use the entire function code to write it. It's not an issue.
What does this lambda colon 0 denotes in this default function? This lambda colon 0, yes.
Like in this case, like if you don't have any word which is close to it, like for example, it might be possible that the word is the last word. Like in any case, like for example, let's just consider this thing. Like suppose if there is nothing apart from Mure, right? Here Mure is the last word. So what would be the case then? Like you can't keep the things empty, right? So in that case,
a default parameter, I think. If nothing matches, or default 0 will be printed.
Yes.
Okay.
Then 0 would be taken into consideration. Yes.
Okay.
So this model too is a like a dictionary of dictionaries.
Yeah, it is dictionary of dictionaries.
Okay. So what will be the key here? Like in the main
the key would be the word. Like for example, America
unique unigram.
Yeah, unique terms.
Okay. And the content will be? That is also a dictionary.
Yeah, it is even a dictionary, and it the second dictionary that I mean the like nested. The second dictionary, the nested dictionary basically is the words. Like it is not necessary that after America every time after repeats. Right.
Okay.
It can be many words. Like after America, it might be possible that that is and things can repeat. Like so, in that case, we can't ignore the words. So for that purpose, we have kept things like, for example, this. Yeah. So for example, after apart, there are many words like as, in, and Tommy's. So these are the words which have repeated after apart. So the probabilities, I mean, have printed.
So this means that these are the next words after apart with the probabilities.
Yeah.
Okay. Thank you.
So yeah. So over here, in the very first case, is we are considering a data frames row. Okay. So like each sentence will be taken into consideration of the data frame. Like each of these sentences would be taken into consideration, and it would be, I mean, the things would iterate. The sentence would be iterating. After that, what we will do is we'll take words. This is an inbuilt function which is given by NLTK. So it's bigram. And in this case, we have done pad right as well as pad left. I mean, true. Like, for example, if there is no word, then it's not necessary. Like, there would be padding done before and after the sentences, so as to avoid any kind of null kind of things. Okay. So you can I have used a split thing because by default what Python does is it takes, instead of taking the entire words, like the number of times, instead of taking those words, what it does is it takes alphabets like T, H, E. So it is necessary that if you are using anything in data frames, then I'll suggest you that you have to use split function so that it would be helpful and you won't get the letters thing repeated. I mean, you can even try it because like if you do it practically, I mean, if you implement it, yeah. Anyone has a question?
Yeah, I didn't understand what pad right and pad left does. Could you explain that again?
Yeah, so in case of any word, like for example, it is not necessary that words always have, like, what if the word is the last part? Like, for example, the word is the last, what I can say that the word, in the sentence, the word is the last word. Okay, so in that case, what we'll have is we can have a none. I mean, like there might be a blank space which might create an error. So what it does is it instead of using any other term, like instead of using null or something like that, because I mean, using null in this case would create an issue. So what it does is it adds none, NONE. So so that it can be helpful for us. Like it won't be, I mean, difficult to like to understand what is apart from this thing. Do you get it? Like it basically adds null or none term after if there is nothing apart from that word.
Okay,
like
thank you. Yeah.
Like it eliminates any kind of spaces. Like for example, when you tokenize word, it is not necessary that, I mean, usually if we are doing word tokenization, then since I have implemented it like manually, so in case if by any chance any kind of space is left, like suppose if after films I have a space left, then this padding would take care of that. Like it would add just none to that. So
thank you.
Okay, so you got an idea about this bigram function?
Yeah.
Okay, so after that, this is the key. I mean, W1 would be the key, and W2 would be the default dictionary part. Like it would be something like just a second, if it is possible, then I would do that. Like I can show you guys. Just a second, it takes a time.
Sonal, I have a doubt that why you have given W1 inside open parenthesis?
The reason why I've given it is it acts like key. I mean, it is not that an issue. Like you can even avoid that. I mean, like it's not necessary that you have to give brackets on that. I was just copying the code from trigram to bigram, and in case of trigram, we use a tuple. Like since there are two words, W1 and W2, that's why I guess the code has copied.
Okay, thank you.
a second. Some issue, I guess just was like I'll just explain it to you and then I'll just demonstrate how model works. Okay, so yeah, so in this case, like I mean, for each and every term, the model keeps on adding the words. It would be better if I would have showed you in any way. So taken to the okay, I'll just rectify this thing. I'll just need a minute. Okay, so before that, I'll explain you guys. So over here, what it does is like yeah, after each and every word, like for example, if a part has 3 things, then it will add up like it will just increase. This function is just used for increasing the count of words, like how many times a word has appeared with respect to the other word. Like in this case, if I say that the number of time America and after has appeared together is just once, okay, in this entire corpus, then you have, then since it is used, like we would be at the end of the day, would be requiring the probabilities. We don't require anything else. So what we would do is, instead of like the entire thing, what we'll do is we'll just, I mean, like according to the probability of formula, like a formula, like where we have the, I mean, the division done at the end with respect to the entire sum. So over here, for the entire word one, like for example, for the entire apart word, how many times the other word has appeared, like so W1 would and W2 would be divided by the total count of word one in this model. So because of that, I guess, as in and Tommy's have been appearing once after apart, so since it is, I mean, the division would be 1/3. So each of them has a probability of 0.33, 0.33, and 0.33. Okay. And then you would be, I mean, in assignments, I have given you to implement trigrams. It is simple, just like you have, just apart from, I mean, in case of bigrams, what we were doing is we were using the function of bigrams. In case of trigrams, you have to use the function of trigram, and you have to implement that thing, and you have to print the probability in the same order. And if it is possible, then you can even construct an entire sentence using this whole scenario. I've even added the references from where you can take like the things, I mean, just you can understand and you can code. But like this is something which you have to do for tomorrow's submission of the assignment. Like this is the trigrams code. By night 9 or 10, I'll upload this code so that you can, I mean, have a look and you can construct the code, or you can even try it by yourself. So this is for bigrams and trigrams. So I was asking that, do you guys, I mean, I have created the code of Unigram, which is which does not use any functions. this is something which NLTK library has given it to us. So that Unigram thing is without using any function. So should should I demonstrate that to you as well, or should I just a second? So should I demonstrate to you, or like should I just upload the code, because I have Unigram code as well?
Hello, ma'am. You just upload the code of Unigram and Bigram.
Okay.
I have one doubt. So whatever CSV file you have taken, that is of the movie review. So from this file also you so directly we will get this file, no? This you are from web link.
I've the assignment PDF I've shared you the drive link as well.
Okay. So you are going to share the drive link also, so that we can able to get that file.
Yeah, and
so
in case of
same file, from same CSV file, we have to create trigram, whether you have done with 1 gram and Unigram and Bigram, right?
Yes, and I have even written the code of trigrams as well. There's just if it is possible for you guys, then you can write the code of what it would be there in the entire sentence. Like, I have not implemented that code for the assignment purpose, but like if you guys have any doubt, then you can ping me, or like you can mail me, then I'll implement that code and I'll just upload it by today 9 p.m. or 10 p.m. so that you can submit the assignment tomorrow at 2.
Okay, thank you.
Sonal?
So yes.
Yes, this is Sandeep. Actually, now these people will are doing assignment online.
Yeah, they'll be doing the assignments.
Okay. So they have to report something, I think, some probability, because we have to evaluate them. You have to.
Yeah,
Okay.
So
now can we see? Yes. Please go ahead. Huh?
Yeah. No, I was just asking them that if they needed a description of that Unigram part, or should I just upload it? Because I guess you will be having another practicals, from 6 o'clock or 6:15, I guess.
No, actually.
Just a second, I'll just. Yeah. Is my voice audible?
Yes.
Yes.
Okay. So I guess there'll be someone to take the, so should I explain it to you more, or should I just upload those things?
No, so Sonal, you explain them. Because there are some BTech student, MTech student. So what I'm suggesting you explain them. Okay.
Okay. So have you? Okay. Then what I'm going to do is I'll just share the link of. This is this Google Colab notebook in the chat itself, so that you can just see it once. And if you have any doubt, then you can immediately ask me, like in the next 15 minutes. I don't have any issues. So I'm just pasting the link. Just check it. Yeah. So here is the link of this Google notebook. I'm just sharing. Yeah, you can access this link, and if you guys have any doubt, you can just ask me.
It's asking for request access. I've sent you the request. You need to accept that.
Just try it once again. I've just changed the settings.
Actually, I got confused. Like, what exactly are we supposed to finish up for the assignment? Like you said, you will share the file. So, what exactly are we supposed to fill?
You have to just calculate the probabilities the way I have did for bigrams. Okay.
And the data set for that we have to use is the movies, right?
Yeah. I mean, I have uploaded the assignment in Google Classroom. You can just check it once.
Yeah, there are 2 assignments in the classroom.
Yeah, even I wanted to ask about that because the second one is for named entity recognition.
No, right now don't consider name entity. I mean, this is just consider
the language model.
zonal language modeling.
Yeah.
Okay, because the due date of that assignment is also 2:30 p.m. tomorrow, I think.
Okay, no problem. First you finish the language modeling part. We will change the deadline. Okay.
Okay, no problem. Okay.
Participants are requested. Okay, if you have find any difficulty, please contact Sonal. I mean, you can raise. So don't. I mean, don't hesitate. Don't hesitate to ask questions.
I'm just sharing my screen to explain that thing. Like since there are no sessions till 6:30, I'm just explaining you guys. Like, is my screen visible?
Yes, ma'am.
Yeah. So the doubt that you had is what if, like, how exactly the model structure looks like. Okay. So the model, since it contains many words, so the model structure looks like something like this. So here you have a word that is C. C might be present anywhere in the entire corpus. So the term C has default, I mean the nested dictionary, which I mean, as I told you, that the thing that padding does, which is none, like it might be possible that after C there might be some gap which is left. So it adds an extra pad for none. And then after C, there are many words like dogma, dreams, has, how, if, it, and it is just giving you a count of how many times these words have appeared after C, so that you can get a total probability of that. And the previous time the model was not working. I mean, we were facing an error. It was because I mean, mistakenly I was passing W1 and W2, which are just I mean, for printing a particular term. Like this representation tells you about how the entire structure of model is. The dictionary looks like. And if you want to print about a specific word, like for example, if I want to see how many times Steve has appeared after maybe say Gutenberg.
Screen is not visible, ma'am.
The screen is not visible?
No, it's visible.
It is visible.
It is visible.
Please check your internet connection. I mean, I can see the screen.
Yeah, so see. Like, is the screen visible now? Like every.
Yes.
Yeah, it's visible.
Yeah. Okay, so you can see over here that after, I mean, Steve is print. I mean, after Steve, Gutenberg comes just a single time. we can, in the same way, like you can just have experiments conducted, like you can have like you can say that how many times after a part is can be printed, or it might be like, so after a part is not there, I guess as is present. So after a part there is no is, there would be an as. So we can check the probability of how many times as is there after a part. So after a part as is once, so that is the reason why we have the probability as 0.3, 0.3 and 0.3 as I explained. So you guys had an idea about how things work?
Yes.
Yes.
I'm over here till 6:30. You can, if you want, then you can ask me any doubts, like by during, you can start implementation so that you won't be burdened at the end.
So participants, I mean, we are here. Okay, I mean, you start implementing whatever you, I mean, doubt you have. Please ask. Don't hesitate. Okay, and please.
Yes, sir. We are implementing.
Okay, okay. And without hands-on, I mean, NLP is a programming subject, and without hands-on, I mean, there is no point to learn NLP. Okay, so hands-on is a very, very crucial sessions. And Sonal works a lot of, you know, I mean, yesterday he works a lot. She works a lot to prepare this assignment.
And like as sir was saying that we can calculate perplexity and entropy, like which are basically used to evaluate the model. And model evaluation is required, but since keeping the time constraint in mind, I thought that it would be really difficult for you guys to do it, I mean, in the very first place, in the first day itself. So and taking the time constraint, because I thought that it might be that the things might get delayed. So I have not prepared the code of perplexity, but if you guys need, then I can send the code to you by 9 or 10, so that you can have an idea. You don't have to submit that perplexity part, but we can use, I mean, you can have a general idea about how models are evaluated, and even those things have a library. And secondly, even I have, I mean, you can always code everything, like even without using libraries. So even I have those things available, like where you are not using any library and you are just coding it hardcore, like you're doing a very hardcore coding without any library. So even I'll share that thing to you, I mean, in today's file, and you can access both the things, like you can do it in whichever way you want.
Thank you very much.
Hello, ma'am.
Yeah.
Ma'am, can you please check that my email ID is added to the classroom? Because I can't see any of the assignment in my classroom, ma'am.
Oh, okay. Can you just paste your assignment, I mean, your email ID in the
Yes,
chat box?
yes.
I'll just...
Yes, ma'am.
Yeah, and for the time being, like if any of you are not able to access the classroom, then here I'm just pasting the link of the Google Drive, which which has all the assignments which would be present, which would be given to you during this entire session. So I've uploaded the assignment in that as well, so you can just check it. If you have any doubts, even I'm uploading my link as well, so that you can directly reach the assignment part.
Okay, ma'am.
This is the direct link to the PDF file, okay? So if you have any, just try accessing this link.
Hi. Actually, how have you given the path for the dataset file? Like, should the file be uploaded into the Google Colab or is from your local
You
desktop?
can just download the thing. Just a second. Just give me a second, okay? हाँ, जो path.
Yeah.
Okay, so sorry. So जो path मैंने दिया है basically उसको तुमको क्या करना है कि तुमको डाउनलोड कर लेना है अपने PC में. मतलब अगर तुम गूगल कोलैब पे काम नहीं कर रहे हो और अगर पॉसिबल है तो तुमको उसको अपने ड्राइव में मतलब ये करना है. एक बार चेक करो, आई गेस वो तुम्हारे शेयर्ड इसमें आया होगा, लाइक शेयर्ड ड्राइव्स में आया होगा, तो तुमको बस उसका लिंक चेंज करना होगा, मतलब उसका पाथ.
Actually, the assignment is uploaded in the classroom और उसमें link है dataset का. You can possibly download it from there.
Yeah, okay, you can.
Yeah.
Hi, ma'am. Actually, my doubt is I've downloaded the file and I've removed the path and changed it to my path in which the file has been downloaded. And I also install externally the module of pandas, but it's not working. It's showing me the syntax error of Unicode error.
Okay, then it must be like, are you using that PDFs that .read CSV?
With normal, you're talking about the raw string.
Yeah.
So I have to use the R before that link, right?
Yeah, just try using that. I guess like I have even encountered this UTF error. I'll just
Still,
send you the solution.
Still shows error.
Okay. Okay, I'm just sending you the solution. You can do like I'm just I mean instead of using R, what you can do is you can write this thing. Like I've just pasted the thing, encoding Latin part.
I did that, encoding Latin and encoding Python.
Still, it's an error. Can you just paste that error in this chat screen once?
Yeah, sure.
Have you used this solution?
Which one?
I've just pasted in chat.
I am not able to see.
Is it visible now? Okay, just a second. Yeah, have you used this one?
Yeah, encoding Latin one, right? Okay, with R also. Let me use.
Hello.
Yes.
Ma'am, also I can't see the drive link, the Google Drive folder link that you said you shared.
Have you opened the assignment? I'm just sharing it in Zoom meeting as well. Okay, I'll just, this is the Drive link.
Okay, got it. Thank you.
Yeah, I guess it may be an issue of the path.
Okay.
No, I'm just thinking like.
Actually, I figured it out. You can just take the particular file and then upload it into your Google Colab. And once the name of the file appears into your directories, if you right click it, it says copy path. So you can just take that and then paste it.
Okay, I'll try that too. Thank you so much.
Sure.
Are you using like your Jupyter notebook? I mean, the Anaconda one?
Yeah, I'm using the Jupyter notebook.
Okay, try doing it in Google Colab. Like it will be good.
Ma'am, have you added my email ID to the Google Classroom?
Yeah, just a second. I'll just
Okay.
just give me a minute. Okay, did you report this problem to anyone else?
No, ma'am.
Okay, then I'm just sending you the thing, okay?
Okay.
Excuse me, ma'am.
Yes.
Ma'am, actually, I had missed certain part of this class. So the main doubt that I had was that so you have shared the link with us. Now this drive link, we have to make changes in this drive link when we implement the trigram.
No, you just have to do whatever I have said you in Jupyter Notebook. That's it. Like you don't have to make any changes in the drive.
Okay. So in my Jupyter Notebook, I will implement the trigram, and then then I will share. How will I submit it basically?
You'll submit it in through Google Classrooms. Like I have turned it in the assignment, so you just have to upload it over there.
Okay. So basically, just the code.
Yeah, just the code, and if possible, like try printing the output of any particular word, like the way I have done.
Right. Thank you.
I've just shared the Google Classroom link in the chat box, so you can just join that link through Swarna. Yeah, you can just join through that link.
Okay, ma'am.
Hi, ma'am. I had a doubt in the code.
Yeah.
So yeah, where you're doing string dot replace and then you're adding the open brackets and the curly braces. So what is that doing exactly? Is it like replacing all the brackets with?
Yeah, with just with nothing. Like it's replacing the entire, like I've created the curly brackets and the square brackets and the curly brackets, the both opening and the closing part. Like the entire thing would be replaced with just like, since I have not given a space, so it would be just replaced by an empty string or a null string, better to say a null string.
I think I'm still not clear with that. So what is the significance of those brackets?
See, when you are processing anything in case of NLP, these brackets would cause kind of hindrance. Like for example, they are first of all, they are of no use, and they would create a hindrance. Like why would you need any time? Like basically what we do in any NLP, the basic of any NLP task is we try to count the words, or we try to count the number of times the words have appeared or something like that. So in that case, we don't need curly brackets or even commas or even semicolons. So that's why these things or these punctuation marks are replaced with a null string, which means it is simple. Like at the end, if you see in the code, like in the line of that part, what I have done is I have created str.replace, then the thing like the curly brackets dot format string dot punctuation. Okay, so this is a kind of function which is used to replace this. I mean, this is an inbuilt function of format where you try replacing the thing that I have added in front of dot. Like even if I add comma over here, it would replace comma as well with a null string. So you can change this.
So we have not added the open brackets, like the simple open brackets, but it also replaces those. So how is it doing that?
It carries something called as inbuilt functions. Like you even see that commas are as well replaced. So a few things are inbuilt which it takes into consideration, but apart from that, any other thing that you want to pass it manually would even be replaced.
Okay, thank you. And one more question. So in the assignment, we have to also predict the sentences. So do we have to like predict from the starting word, or are there any sentences which we have to complete?
No, it depends on you. Like you can even take a sentence which is like which you want. Like for example, whatever suits you. Like you have to take the head and you can predict the next letter, which would be of highest probability.
Okay, yeah, thank you.
I also have a doubt.
Yeah.
In the code where we are calculating the probabilities, the second last code where you are running a for loop for W1 is equal to model underscore 2. Could you get that code where we calculating the total count?
So should I share my screen?
Yeah.
Yeah, okay. Just a second. Yeah, so my screen is visible. Yeah.
Yeah, scroll down a bit. Yeah. That's okay. This one or Bigram one, anyone. You can scroll down a bit. Bigram one.
Like this one?
No.
Okay.
Yes, this one. This for loop for W1 is equal to. Yeah, I couldn't understand first. What is this model underscore 2 W1 stores? This W1, W2.
W1 and W2 basically stores the word. Like for like, just give me a second. I'll demonstrate it to you. This is W1.
Okay.
Okay. This is the entire model. Like if I. So this is the entire model. A part would be a key. Like the way dictionary works, it has a unique key. So a part is the unique key. That would be present.
That is W1. Okay.
That is W1. And W2 could be anything from as, in, is, or Tommy's.
Okay, so these words are occurring with a part.
Yeah.
Okay. And now also scroll down a bit. And then after this, what we are doing, we are summing the values of all the keys, this
Yes.
apart values. Okay, we are summing these value. Then again, we are doing a loop from
So that
W1.
for every word of W2, we are doing a loop. For as we are doing a loop for so that we can get up the probability for each of these words.
Okay, for apart, as, apart, in, apart, is, that way.
Yeah.
Okay, okay. And one more thing, see, you have written that the number of times America after Bigram has existed is 1. It is showing in the code. But if you refer the CSV file, it is 2 times. If you just use Control F and type America after. So it is showing.
It might be because of the space case that might be present. Like it might be present. There might be anything which would be different between the two America and after. But just give me a second. I'll check it once and then I'll get back to you.
Yeah, yeah. Okay, sure.
Okay, so it might be the case that I have taken just a few top 1000 documents. I'm not considered the entire document. So it might be the case that the second America after might be occurring in another set of the document.
Okay. So have you mentioned anywhere specifically that we have taken 1 to 1000?
Yeah, actually, I have initially while training the document, see when you see the lines of code, then after in the data pre-processing part, in train data centi, I've just copied this thing and then dot head is equals to 1000.
Okay, got it. Yeah. Okay.
Good evening to all. This is Sandeep actually. Now we are going to end the session around 6:45 p.m. So please ask as many as, if you have any doubt, please ask straight away to Sonal. Okay. That's all.
And if you guys have any query, I'll be sharing my mail ID as well. I guess you'll have my mail ID in that classrooms thing. So you can even ask me anytime.
Even you can ask me too also.
You can ask Sandeep sir as well. He's very good.
Yeah, in CC also. Okay, and Sonal will give it. That's fine.
Just a last thing about the assignment. Sonal, do we have to only submit the trigram approach code? That's it?
Yeah, you just have to submit that trigram.
Submit the trigram approach. Okay, we have to upload it on the Google Classroom, right?
Yes.
Okay, okay. Thank you so much. Okay.
And tomorrow we also have a lab session on parsing and part of speech taker, name entity, everything we will cover tomorrow. So if you have a doubt in this language model, you can ask tomorrow face to face to Sonal also. Sonal will be available on that particular time for just if you have any doubt, please write her an email if you have a doubt or if you want to ask.
Sure, sir.
Arushi, I can't able to resolve my path issue. This is your error. So just check your collab. You can upload the corpus file. You can upload, or also you can access through Google Drive also.
Sir, I've tried both ways. I've even upload the file on the Google Drive.
Okay, but you can't access the file, text file.
So I can access that, but in the Google Colab notebook, it shows error.
Okay, what is the error? Arushi, please share the error. With us. You can share the screenshot of error in WhatsApp group also. We are also in a WhatsApp group. Okay, Unicode error. Now see, the easiest, this is, something like encoding UTF-8 you to write. Now, if you copy paste everything on a, Google, they will give you answer. You have to just write encoding. This is a Unicode error. This is very normal error.
Basically, the data set, like I also face the same issue. So the file has to be, the path of the file has to be relative to your Jupyter notebook path.
Okay.
Yeah, it might be possible that you are using try using that double slash thing.
Yes.
Once I even face the same error, so it was solved by that.
Yeah. So this is not the big error. Either you can write double slash, single slash, or something like encoding UTF-8. This can be, you can get rid of this error.
Okay, I'm just sharing the name which you have to while submitting the assignment, you have to write a particular name. You have to give a particular name to your file so that it will be unique for every person. So I'm just sharing the format in which you have to name your files in the chat box. So please take a note of that because you have to submit in this way tomorrow. So just check the chat box. It is ID, which is your ACM ID _ assignment name. The name of the assignment is language modeling. So whatever your ID is _ language modeling.ipynb. Yeah, candidate ID. So I'm just giving an example of that. Like for example, 308 is your candidate ID _ the extension of your Python notebook will be ipynb. No, actually, I've just explained you guys the Bigram code. The thing which I want you is you should learn the trigram code. But the thing was, since I have just coded everything in in the same notebook, and I needed to demonstrate it to you, so I've shared that file. You just you can take hint from that trigram and try implementing it yourself. That was the thing. That was the problem statement. Basically, I had to give you bigram implementation, and you have to do the trigram yourself. No, you have to use libraries. What exactly I have to explain? Like what you have to do in the assignment. Oh, okay. So what you exactly have to do is you have to implement the trigram code. It is just like the bigram one, apart from the fact that you'll be using 2 words in that thing, and you have to print the probabilities. Plus, and there is an extension to that assignment as well, that you have to predict the most appropriate word of the next text. Like for example, according to the highest probabilities that you get. For that, even references have been given to you in that assignment part. You can refer to there is a code for that thing as well. So you just have to refer to that code, and you have to implement it like by yourself. So I've even given you the references. I'm even pasting the reference over here again, so that you can get a clear idea about what you actually have to implement. But the thing is, just understand that code. Okay. So should I paste that link? What you have, the text part? Yeah, and can I just take just 5 minutes? Can I just extend this session by 5 minutes? Just give me 5 minutes so that I can just share you what else, if you are already done with that, and if you want to explore unigrams in a nicer way. So I'll just give you a brief of what you can do. Like, just give me 5 minutes. Yeah, so my screen is visible, right? Yeah, so yeah. The code which I have shared with you is just related to assignment, and the code which I'm telling you now, right, the explanation which I will be giving you now, it has nothing to do with your assignment. It's just for your knowledge. If you want, you can implement this as well. So since we have been using every functions of NLTK like bigrams and trigrams in the previous code, if we are not given any kind of libraries, how would we implement this unigram or bigram or trigram thing? So this code is really a hardcore one. So you can just see, I'll just be explaining the code models, and if you want, you can ask me any doubt related to that. So initially what I have done is I've just the same data cleaning part that I have done in bigrams and trigrams, I did the same. And then I created an entire word list. So since in case of bigrams and trigrams, because of that single function, we're not supposed to do these many code by ourselves. Like we did not require anything apart. There was just a function given to us, and we were not required to do anything apart from that. We were just passing the sentence, and it was giving us the bigrams and trigrams of those sentences. So if you plan not to use libraries, then you have to do all these code. Like for example, you have to take care of the sentence, you have to tokenize it, you have to join those sentences into a list format, and then you have to create the word list. And since as we can see that the model contains unique, the keys of the model are unique. Okay, it was taken care by the Bigram library. However, when you code it by yourself, you have to take care that the words that you have are unique. Okay, so this is the function which is basically written to write the unique words. Then after which this function used to give the count of words. Like these are the word counts that I got. And this function just contains the data. So this is the word count that I got. Then after that, there are few stop words which you can make it to 0. So I just this is the because in this case we need to identify every sentence. Like you have to separate the sentence. So I have used a sentence tag. This is a sentence tag which is present. So it is even repeated. So and it might infer the probability count. So you need to make this 0. And this is the way which you do it. Like in case of Unigram model, the probability that the Bigram model calculated was directly given to you all. In this case, we calculate the probability by using this function that sir has said you guys. So we do this, and to eliminate that 0 error, because 0 error were present in this entire corpus. So to avoid that, we used a logarithmic function. So the probabilities was given in that logarithmic format. And then an example of that over here. Like, so the probability that the word the and that are away is this. And similarly, I calculated the entropy. The entropy formula is this. This is a measure to calculate the perplexity first. So this is just the implementation. If you want, and even I can share the link so that you can go through it. Okay. So should I share that link?
Yes.
Yeah, it would be great.
Yes, ma'am, please.
So here is the link of that Unigram. And if you have any doubt, just a second, I guess I have shared it privately. Yeah. So this is the link. And if you guys have any doubt regarding this code, then you can surely ask me. I'll be there tomorrow as well, so you can ask me. And if you want, then I can even implement the bigrams part. But it is just like the unigrams one, apart from the fact that you have to change the formula of probability and nothing else. Okay, so I guess it's time to end the meeting. Yeah, and if you guys have any doubt, please do feel free to contact me. I'll be there. I'll be there to help you. And yeah.
Thank you. Thank you, Sonal.
Thank you, sir. Thank you, sir.
Yeah. Thank you. See you tomorrow, 3 p.m.
Thank you.
Okay.
Thank you.